Imagine AI is a Rubik's Cube.
Sorry, imagine AI is a Rubik's Cube.
And you just need to align need to align the colors. It's like the weird meme on Twitter about like shape rotators or something.
Oh yeah. No, my roommate jokes all the time. You're like the most stereotypical shape rotator.
The cool shape rotators now do AI alignment.
That's right.
You're speaking like ChatGPT.
Oh no. I'm sorry.
I'm a language model by OpenAI. I don't commit to any particular definition, but
I think every story of alignment that is actually scary to me involves AI systems basically deceiving humans in some way. Like if the model is totally honest all the time, then surely you can just ask it, like, is this, are you going to do something dangerous or not, like deliberately? And it's like, yes, I am. Then, okay.
Collin, you are a second-year ML PhD at Berkeley, working with the one and only Jacob Steinhardt and Dan Klein. Your focus is on making language models honest, interpretable, and aligned. And you've also worked on multiple benchmarks, including apps for coding from the math dataset and MMLU for language understanding. More recently, you've published on Archive, Discovering Latent Knowledge in Language Models Without Supervision, a paper that received a lot of praise on Twitter and less wrong, including from Eliezer Yudkowsky, who said that this work was very dignified. You've additionally published a less wrong post explaining how this last paper fit into a broader alignment agenda. And we're going to be talking a lot about this paper today. So thanks for coming here today.
Yeah, thanks for having me.
So a surprising fact about you is that you once broke the official world record for solving a Rubik's Cube in 5 seconds.
Yeah.
And I remember watching those like Rubik's Cube video when I was a kid. And I think it was not you when I was watching other ones, like, I don't know, in 2011 or something.
But you never learned how to solve it or anything?
I once did it in 50 seconds.
Oh, nice. Okay. Nice.
So I did those, I think it's F2L.
Yeah.
I learned some of these. But yeah, I wanted to know, like, in your experience, was the 5 seconds pure luck?
I would say it was some luck and not just pure luck. So, I mean, I think at my peak, I was maybe like, in terms of average for like solving it across many solves, I was something like in the top 10. And so I think it was like, you should have to be good enough to have even a chance of getting the world record, but also certainly luck was an important part of it. I mean, this is always true, especially for like the single best solve where you're really selecting for that. So yeah, definitely part of it.
Does it happen that sometimes you have something that requires only like 10 moves or something?
Not quite that easy. So if I remember correctly, so first of all, every Rubik's Cube can be solved in 20 moves or less. So this is, sometimes people call it God's number. But actually most configurations of the cube can be solved in, I believe, 16 to 18 moves. Like it's actually sort of concentrated in a, kind of a small range that's less than 20, but still kind of close. On the other hand, the actual methods that people use to solve it efficiently, which is sort of more computationally efficient for a human to solve or to think about, that's less move efficient. So that's, I want to say, more like 50 to 60 moves or something. So it's more like, maybe if there are 4 stages to solving it, it's like the last part it was sort of easy or something like this.
So you've arrived in some kind of easy last cross at the top.
Something like that, yeah. So the way it works is you first solve the first 2 layers. And this is actually the part that takes the longest in some sense, but and that's very intuitive and so on. And that was sort of the part that I was good at. And then after that, you solve the last layer. If you think of it as 3x3, it's like the first 2 and the last one. And then for solving the last layer, you usually do 2 algorithms. So one for orienting the pieces and then one for permuting them. And so in that particular solve, I believe the last part, like the permuting, that was already solved by default. And that happens maybe like 2% of the time. So it's not extremely rare, but it was definitely lucky. So.
And you've also made like some YouTube tutorials.
Yeah.
You had a choice.
Actually, in fact, so before I even get into that, one fun fact is I learned, so F2L, which you alluded to before, this is the first 2 layers. I actually learned this from Andre Karpathy. So he, so back in the day, he had, I think, the best tutorial for how to solve the first 2 layers. And yeah, I like I said, that's sort of the part that I ended up becoming good at. I was actually like very bad at the last layer, relatively speaking, because I didn't like memorizing algorithms and things like this. I'm definitely much more into the intuitive aspect of solving the cubes. And I learned that from him. So those.
You can do like the first 2 layers by just like thinking about logic, or like what are the like ways of doing it in general. And I believe you need to like put somehow 2 things together from the first and the second layer in a way that you can balance it and do like the edge thing at the same time.
Yep.
So maybe there's something about being good at Rubik's Cube that makes people good at deep learning research.
I wonder.
So yeah, how did you shift from maybe in your being like 14 years old and 15 years old and thinking about Rubik's Cube to becoming a deep learning researcher publishing at NeurIPS and iClear?
Like how did I get into this?
Yeah.
And yeah, so I actually originally, so I mostly cubed very actively in middle school and high school, and sort of stopped around the end of high school. And I was originally planning on doing physics, or that was the thing that I found most exciting for a very long time. But at some point I sort of heard more about AI, and I think I became convinced that this would just be this very big deal, or had a good chance of being in this very big deal in my lifetime. And I sort of became disillusioned with just doing research that seemed interesting, but not really deeply important for the world. And so that's when I started learning about computer science and AI sort of at the end of high school.
When was that in terms of years? Like 2015, 18?
This was like 2016, maybe.
Did you read like anything about AI that made you believe it was kind of important?
Yeah, so I guess I met some people. So I actually went to the summer camp in high school where I met, for example, Jacob Steinhardt and some other people like Paul Cristiano and
not a Rubik's Cube summer camp, but
no. So yeah, this is more like a lot of like most of the students there did like math Olympiads and things like this.
Did you do any math Olympiads?
No, I didn't really know about math Olympiads before then. So actually, I guess a bit of a digression, but in middle school and high school, I was actually homeschooled, so I mostly just taught myself. So this worked out really well for me because it meant I had a lot more flexibility in learning like what I wanted to learn. And
how did you go from like knowing that like AI is important to doing like LLM research? I guess like if you met the first person was like Jacob Steinhardt, Paul Cristiano, you might be like LLM by them.
Yeah. So right. So these people were sort of concerned about risks from AI, and this is basically what motivated me to get into this. I mean, initially, these sorts of concerns seemed sort of plausible but not obvious, and I felt like I couldn't actually evaluate them properly. I didn't have the background to do so. But it seemed sufficiently plausible that I decided to spend a lot of time learning more about it. And so I guess just on the side, I started reading a lot about it and sort of gradually over time became convinced that I should at least likely do this. And then I became convinced that I should definitely do this and so on.
Did it appear like, more and more important as time goes? Like maybe in 2016, it wasn't that pressing, but now it feels more pressing.
Yeah. I mean, certainly, I'm sure we'll get into AI timelines and progress and things like that, but certainly it feels much more urgent than it did before.
Yeah, you mentioned timelines. You're doing a PhD in CS, but more in machine learning with Jacob Steinhardt. He's famous for having those benchmarks. So math, apps, MMLU, and I think he hired some forecasters to do some forecasting about when we will reach some level of accuracy on math. And famously, we reached like 50% in 2022 when it was expected to arrive in 2025. So yeah, did it surprise you at all, these like performance in math? I think you were an author in math, right?
Yeah. So I was an author on that. But I should mention, I think like Dan Hendricks gets a lot of the credit for those sorts of those papers, and he really pushed for those. So, but yeah, I was lucky to help. So I feel like I was certainly impressed. I think I personally wasn't as surprised, but I think at that point I had already had I was relatively bullish on AI progress already at that point. And so, I can get into exactly like why did that seem like not totally crazy to me. But I mean, I think part of it is if you just look at a bunch of benchmarks in ML and especially NLP, a lot of the time they come out and performance is initially really low, but if people haven't really worked on them, it's often the case that like progress really jumps pretty quickly, and you get like pretty rapid progress quickly. And so I think just because accuracy, I think, was 7% or something initially for math. I didn't really expect it to stay like that for very long. And I think I also had this intuition that like there's a lot of low-hanging fruit for math. And I mean, we sort of solved this with Minerva. Like it was based on very simple ideas and scale. And, you know, it wasn't totally trivial or anything, but it was sort of getting at a lot of that low-hanging fruit that I thought would be there. And so I think it was less surprising to me, but it's still very impressive, to be clear. And
so what were the low-hanging fruits?
Yeah, I mean, things like chain of thought and like consistent, or like, you know, run chain of thought a bunch of times and then take majority vote or something like this. And I think they did like more pre-training on like mathy data. I forget exactly what it was. Maybe it was archive or something. And little things like that, which are really straightforward, but make a huge difference. I mean, I think we've seen this just over and over again in ML. It's like really simple ideas are extremely powerful. I mean, even if you just look at like what are the most important deep learning papers, it's like these, you know, it's like ResNet. It's like, you know, replace f of x with f of x plus x, and it's like, okay, suddenly you can like train much deeper networks, and it like it's wild how simple these ideas are. I mean, similarly with, you know, batch norm, it's like, okay, you normalize things, and this isn't to say it was easy to get there, and like these were, you know, it's hard to come, you know, it's always simpler in retrospect, but that doesn't change the fact that these are really simple ideas that are really powering all this progress, and that's sort of wild.
It's kind of counterintuitive to have a ResNet pass the, you know, have the X transit to like a more advanced layer. Like you wouldn't do it before, but right now it's like, it makes a lot of sense. But I guess this is kind of a parallel to your paper that is like kind of like obvious in retrospect and kind of simple, but people, this is kind of very useful at the same time. But I believe like people who were like built math thought that like the math problems were kind of hard. So math was released in 2020 or 2021?
I believe 2020, late 2020.
Yeah. So if something is released in late 2020, you don't expect it to be solved like 1.5 years later, right? You expect it to take a little bit more time.
I don't know. I mean, if you just look at normal NLP benchmarks, it seems like a lot of the times they're released and you know, people try to make them hard, and then a couple years later they are basically solved. I mean, to be fair, I think math is not solved by any means. But I wouldn't bet strongly against it being solved in the next 5 years or something.
Do you remember what you've done on this paper? Like, did you collect data? Did you run models? What did you do?
Yeah, so it was a mix of, I mean, all that, like collecting data, running experiments and baselines and things like that. So we also tried some early version of something kind of like chain of thought, where, I mean, basically we collected math to have solutions, like step-by-step solutions. And we tried to train a model on this, but it seemed like it didn't actually help in that case and made things worse. And now it seems like if you look at various results with chain of thought and so on, actually need sort of large enough scale for that to help. And if you do have small enough models, then it actually hurts. And so you actually see emergence there. That was another thing we tried. So yeah, things like that. And
so I guess Minerva kind of picked those low-hanging fruits, train on archive source, I think, and reach 50% of accuracy. And I talked to one of those Minerva authors at NeurIPS, asking him if you know, getting superhuman level in math or gold medal in math was like very far away. You mentioned Dan Hendricks. I think Dan Hendricks told me once that some other people think that we can get like superhuman in math in a few years. And then the number that keeps coming is something like gold medal by 2026 or superhuman level by 2026. So you're saying math is far to be solved. In my opinion, IMO in math is kind of hard to get. Do you think gold medal by 2026 is possible, like more than 50% likely?
It definitely seems very plausible. I think I don't feel super strongly either way. I feel like my gut is like, I don't know, it seems maybe 50-50 or something. Maybe a bit less than that, but somewhere in that range. I mean, another thing, so you mentioned that Jacob, my advisor, like hired some forecasters and so on. And our group also, just for fun and for practice and because it would be interesting and so on, we also did some forecasts of ourselves, for ourselves. And one thing I took away from that was often one of the key considerations for like what will performance be on this task is how hard will people try to solve this task. And so, for example, if you know, the entire ML community just tried really hard to solve math, by 2026, then I would bet like, I don't know, maybe like 75% or something that we get IMO by then or something like that, maybe higher. And but like right now, my sense is there are like maybe a couple groups that are aiming for that, and so it also depends on how much energy and effort is actually put into that.
So the question is like the time it takes between just like people solving some like toy math problems to like they're being close to solving like gold medals, and then it becomes like almost like a trophy, like, you know, DeepMind wants to, you know, solve math. And
no, this is why it seems more plausible. Like if it were some kind of random benchmark that people didn't really care about, then I think it'd be definitely less than 50%. Yeah, I mean, maybe I would actually put it at like 1 in 3 or something, but definitely in that range of like very plausible.
If we talk about like other benchmarks like apps, MMLU, I think we've seen like results also on these. Like, did you update at all on the progress this year, or were you like already like with like short timelines? And
I think I didn't update that much on progress this year because I already had relatively short timelines. That said, I do think I did spend some more time thinking about timelines. So I guess so back in maybe it was like March or April of 2020. That's when I actually started thinking about timelines for the first time. And so I had lots of conversations with Dan Hendricks actually around that time. And so I think the initial thing that was impressive was like BlenderBot back in the day. And so this was before GPT-3 a little bit. And that was my first time interacting with an NLP system for real. And even though it was pre-GPT-3, I found it very impressive. And so I think, so that's when I started really thinking about timelines.
What does BlenderBot do?
It's just a dialogue system. It's like chatbot, but it's definitely better than I expected. And even though it probably would be pretty unimpressive by today's standards at this point. But anyway, so I thought a lot about timelines back in 2020. So partly because of that, and then partly after GPT-3 came out, and just seeing like the progress in NLP was very impressive. So I think that was sort of what informed a lot of my timelines. And then, I did spend a little bit of time more recently just thinking about like updating that a little bit, and mostly thinking about like, you know, what do I think is like the path to AGI or something like that. And I think my conclusion was like, it doesn't seem as hard as I would have thought, basically.
So between people who think about those things, talking about timelines is natural. But imagine that you have like a random deep learning researcher looking at this. What do we mean by timelines, and what do you mean by AGI? I know there's like not one definition, but I guess like timelines is like timelines for what? Transformative AI, self-improving AI, AGI. What do you think?
Yeah, this is a great point. Like I think I don't personally feel too wedded to any particular definition of AGI or transformative AI or human level AI or anything like that. I think, and so actually my when I say timelines, I often implicitly mean when do I think it's sort of 50-50 that we would have these sorts of systems. And usually when I imagine these sorts of systems, I guess I'm a little imprecise about it in the sense that sometimes I mean just when is it basically human level on like the tasks that we care about, but that's also a little ill-defined. Like, are we talking about median human, or are we talking about like expert human or something, like across every domain or what? And so on. I think for me, the relevant, or I think a milestone I often think about is like, when will we be able to automate AI research? Because like there are these like old classic arguments about recursive self-improvement or something, and I'm not sure if I buy the like old classic story of that, but I do think there's important truth to that of like, actually these systems could sort of accelerate future progress in AI, and that could be very weird and different. And so I think that's a very salient measure I think about, but I think there are lots of reasonable choices here, and I think I would probably give different answers by maybe up to like 5 years in either direction, depending upon the exact definition.
So up to 5 years, what's the when do you think we're going to get something that can automate AI research, like this decade or the next one?
Well, so I'm also being imprecise here because of what does it mean to automate AI research? Is it like, is it able to write a median level like NeurIPS paper, or is it something?
A Collin Burns paper.
Well, but it also depends on what you mean, because like I don't really work on capabilities. Like I'm not trying to make performance on standard benchmarks as good as possible. I'm definitely focused on things like emerging problems and like how do we even model this and so on, and like what are the like methods for doing this at all. to get any progress on this problem in the first place. But that's not the relevant type of research for automating AI research and speeding up progress. For that, the relevant thing is more like, can we just like invent transformers or something like that, or the next transformer? And
so it seems that for those kind of things, you need to run experiments.
Yep.
So you need to have something that can automatically write code, run experiments, and then think about what experiment to do next based on the previous experiment. And after all this, being like, if I submit this to nurips.cc, I might get an 8 and get accepted.
Yeah.
This seems pretty hard. But then if you just think about like one conceptual alignment paper, maybe you don't need all those experiments, right?
So I think it's a little complicated. Like there are many different ways one could imagine automating AI research or AI alignment research. So for example, with AI research, you could also actually just have some metric of like what is performance or something. Like suppose you're just given this data and you want to maximize, or like minimize perplexity on this test data, like just find the best architecture for that or something. And that does feel more like, okay, maybe you can just like optimize that sort of directly, which might lead to superhuman performance because you have this explicit metric that you might care about. On the other hand, yeah, I think in some ways, like maybe something that's more conceptual and like where you don't need to run experiments and so on, maybe that's actually easier to automate. And certainly like this is one of the main approaches that OpenAI is taking, for example. Like let's try to automate AI research, and perhaps we can start doing this soon. And I mean, I'm somewhat sympathetic to this, or I think in some ways I'm optimistic about alignment and relative to many people who work on it. And so I think I think there's a reasonable chance this works, but I also definitely wouldn't bet on it, something like that. But I think it's like one of the things that we should try among other things. And so it seems very plausible.
So do you think this decade we will have people like using AI to produce new ideas, or I don't know, just like speed up their research by like 10% or even like 25%?
Yeah, I mean, for what it's worth, I think even already just having access to like GitHub Copilot is already like, I don't know, like it probably speeds up my coding by like more than 20%.
But does accelerating your coding accelerate your research?
Right. So it's like, okay, what does that mean in terms of overall research productivity? And it's like definitely less than 20% then probably, but yeah, no, I can imagine like actually pretty substantial gains this decade. Yeah, plausibly in the next 5 years, but I feel less sure about that for sure.
So in the next 5 years, let's say in 2027, you log into your computer and you're like, I am stuck on this, and here's my problem. And the AI will be like, have you tried this? Or we'll be like, this is a new idea I thought of. And we might just say like, I think this is the paper you should be writing, and gives you like an 8-page PDF.
Yeah, I would bet against that particular, like at that level. But I think certain aspects of that feel easier than others, and so I could imagine something kind of in that direction, but not quite that good. And it also depends here. Like I guess I'm currently often talking about like when do I think it's 50-50? But I think actually that's not the most decision relevant thing. And so I actually feel relatively uncertain about that. Like my numbers for like when is it 50-50 we'll have this thing. But I feel like the more important thing is like, is there a pretty good chance that this will happen soon or something like this? And so I think for me often I care more about like acting as though things happen soon, because I think that's the world where like what I do matters the most. And it feels sort of safer.
Some people say the opposite, say that if you just like have very short timelines, then your work doesn't have any impact. So you need to like behave like if you were in a world with like longer or like medium timelines.
Yeah, I don't really buy that. Or I feel like you can do research now that has like an important effect even in the next few years or 5 years or 10 years or something. So
good transition to your research. So yeah, you've written Discovering Latent Knowledge in Language Models Without Supervision. I think this paper is quite simple, but both like very insightful. It's been discussed a lot on Twitter and that's wrong in the past few weeks. But maybe assuming the audience doesn't know much about language models and all the things, maybe can you just like give a quick summary of your paper, like in the big lines?
Sure. So okay, so what is the problem we're trying to address? I think, so I will give sort of the long-term motivation. So I think we don't talk about this, or don't talk about all of this in the paper, but I think it's important and able, like, I think we can do it given what we've talked about so far. So I think AI systems are becoming much more capable very quickly. I think language models especially are just seeing very rapid progress. The thing is, we currently basically don't know how to get these models to tell the truth. So we have some techniques for, like, okay, maybe we can train models to imitate truthful text or something like this. This is sort of the default approach that we have for making models truthful. The thing is, like, models can also be more capable than humans, and I think this will become certainly true in the future. In which case, I think that standard techniques for making models truthful just will break down. And it's also worth noting that I think even with current techniques for making models truthful, it, like, doesn't always work in practice. Like, for example, OpenAI is, like, trying really hard to make models truthful and like avoid hallucinations and so on. But ChatGPT still, like, makes stuff up all the time, even if and they don't know how to completely avoid this, as far as I can tell. And so this just seems like an issue that is like a real problem in practice today that will become, I think, much more severe in the future. I think more severe in the future, both in the sense that, like, if models lie to us, I think the consequences could be much more severe, and also more severe in the sense that it's harder to actually avoid. Like, we don't really know how like, it's sort of clear that our techniques will not scale to those models.
What do we mean by being truthful or lying here? Is it like purposefully, like, lying, deceiving?
Yeah, so I think there are different notions of truthfulness and honesty and all these related terms. I don't feel very committed to any of these particular definitions, but I can still say some things that are maybe helpful here. So
you're speaking like ChatGPT.
Oh no, I'm sorry.
I'm a language model by OpenAI. I don't commit to any particular definition, but I think.
So okay. So what do I mean by truthfulness? So I guess, first of all, to answer your specific question of do I mean models, like, are models deliberately lying, and is that what I care about? I mean, currently models, I think, don't really deliberately lie in a super meaningful sense. I think it depends what you mean. So I think our models hallucinate stuff and, like, make stuff up because they sort of predict plausible text, not factually accurate text or anything like that. But, you know, in some ways they can also lie if you, like, prompt it in a way that causes them to deliberately output false things, sort of knowingly in some sense. It's not clear what that means exactly. But I do think once you get to RL systems, then I think you can get more egregious forms of, like, deliberate lying. Or this is a strong prediction I would make about the future, and this is the sort of thing that I'm concerned about. And so, for example, if you just maximize some reward, like, I mean, let's just say, like, do humans like this or something like this text that I produced, then it sure seems like, you know, sometimes humans would not like to know the truth. You know, if there's some inconvenient truth, or, you know, if the model behaved poorly or something, but it can sort of hide that fact from the human, then it might have an incentive to lie there. Or you can imagine much more. You can certainly imagine much more malicious forms of lying as well, where it's really deceptive and, like, really trying to manipulate the human. I mean, we also see now with, diplomacy is sort of, in some sense, solved, or like, there's been very, very impressive progress on that.
Can you maybe remember our listeners what is diplomacy?
Yeah, so diplomacy is this board game where basically I think there are 7 players, and you're sort of in charge of this map, like Europe in, like, the 1910s or something like this. And unlike most board games, there's a very large focus on negotiation, and so this includes cooperation and also lying. So it's sort of famous for lying and backstabbing and things like this. And it's very open-ended, like how you can just talk about whatever you want, like alliances and so on. And
are you good at diplomacy?
I've never played diplomacy. I'd really like to, though. It sounds like a lot of fun, as long as it doesn't ruin friendships. I'm not sure exactly what it's like in practice, but anyway, so there's some recent work by Fair, by Meta. They created this model called Cicero that does diplomacy. And I think it's not totally clear just how good it is, but it does seem pretty good. And so they claim it's something like in the top 10% of humans who played at least one game. I think I'm just not sure what that means exactly, but it's probably like at least good. And so I'm not sure if it's solved or what, but it's seems pretty good. And so
I think it was like blitz diplomacy, so with like short amount of
that
time.
is true. Yeah. So right. There are all these sorts of qualifications. I'm not sure. Like I don't think this was super surprising to me. Like if they, put effort into this, I think I would expect them to be able to do this sort of thing. But
I don't want to come up as like this guy who just like nitpicks and be like, oh, but it was blitz diplomacy. No, it is impressive. I am impressed.
Yeah. So in any case, so they've, in some sense, they've solved diplomacy or made very substantial progress on it. Now, the way they trained it, they certainly claim that it doesn't lie, or at least deliberately. And I think that's, in some sense, seems plausible given the particular way they trained it, but not totally obvious to me. But I think the more important point is just, in the usual version of diplomacy, if you just train a model to literally maximize reward, then it just seems very easy for this to result in lying and backstabbing and things like this. If you get an advantage from lying to your opponents, then you should be able to do so. And models should be incentivized to do so. Then there's some question of like, does this sort of thing actually happen in practice? And I think the answer is definitely not right now with current language models, but I think you can imagine these sorts of things more seriously once you have future language models that are trained with RL to do open-ended actions in the real world, where there are actual advantages to deceiving other humans for one reason or another.
So you're saying basically that right now they're not incentivized to lie, but sometimes lie in some games because, I don't know, in this game it's incentivized, but not in like traditional chatbot use case. So like ChatGPT is not incentivized to lie to us.
Right. I mean, it does also depend on exactly what you mean by lying. So for example, I think you can argue that, when ChatGPT says things like, oh, I'm just an AI system, I don't have any opinions whatsoever, or something like this, it's like, well, what is that? Or like, I don't know the answer to this, I'm just an AI system. Like, I mean, certainly the way it was trained incentivizes that sort of response, and that sort of response is false. Now, is it trying to deceive the human? It's not totally clear what you mean by that, and to what extent that is true, but certainly I think that's in the direction of lying, or that feels like one type of initial example of that. On the other hand, lying also suggests something like the model is aware that it's lying, or knows the truth and is deliberately saying something that is false. It's also not clear what it even means for these models to know things. And so if you want to claim that a model is lying, you sort of have to also show that it knows the truth. And it's like, well, okay, well, what does that mean exactly? And
it's a perfect transition to your paper, yes. Trying to discover the latent knowledge in those language models.
Yeah, so in our paper, we basically show that if you just have access to a language model's unlabeled activations, you can identify whether text is true or false. And so just to spell that out a little bit, I think one intuition is, suppose I literally just had perfect brain scans of your brain, and then I like showed you some examples of true-false statements like 2 + 2 = 4, or like snow is white, or whatever it is. Capital of the United States is San Francisco, which is false, and so on. Suppose I did that and was just measuring your brain, and then I could tell, like, do you think this input is true or false? I think the hope or intuition is that we're doing something kind of analogous to that. Now, there are lots of subtleties here. Like, what do we mean by knowing and truth? And so, like, these are really important, and there are lots of subtleties. So, like, but that is one high-level intuition for the type of thing we're trying to do. And so I guess going into this, it wasn't clear to me that this sort of problem should be possible at all. It's like you're just given these vectors, like these activations, like nothing else, and you have to identify this is true, this is false. It's like, how do you do that? But like one of the main ideas of the paper is there's actually a lot of structure here. So in particular, truth is sort of a special feature in the sense that it is logically consistent. Okay, and so for example, if you think that X is true, and you're sort of like a rational agent or a consistent agent, then you should think that not X is false. Okay, there are lots of logical consistency properties. So you can also consider it and, like if X is true and Y is false, then X and Y is false, and so on.
But I think something like, I don't know, Elon Musk is a good CEO of Twitter.
Yeah.
Can we actually make it true or false, or do we need to have those like sentences like 1 + 1 = 2 that have like an actual ground truth?
Right. So we definitely, so in the paper, we just focus on clear-cut cases. I think it's unclear what you should hope for in less clear-cut cases. And so for simplicity, we don't focus on that case. And so we do focus more on cases like 2 + 2 = 4. Except in this case, it's more complicated than that. It's more like the specific tasks we do are things like natural language inference and sentiment classification and so on. Things where there's just, you have some problem and it has some answer, and then you want to know, like, is this answer true or false, for example. And where human evaluators sort of agree on the answer. So it's pretty clear cut. But I do think it's not obvious what we should do in less clear cut settings, and I think that will be important for future work probably.
I think when you start reading your paper in the abstract, you talk about misalignment, like the language model could be misaligned with the truth. And this is a podcast about alignment. So can you like explain what you mean by misalignment here? Is it trying to deceive us, or just like align with something else than the truth?
I mostly mean it in the second sense. So specifically, how do we train normal language models? Let's just say pre-trained language models like GPT-3 or whatever. And the way we do it is we just have it basically predict the next token for a bunch of text on the internet. And my claim is just, okay, you can train it in this way, and then you can prompt it in like a 0-shot or a few-shot way, and you can get some answers from it that are usually pretty good if the model is big enough and so on. But all it's doing, the reason it is accurate or is like able to solve a bunch of tasks that we care about, like question answering tasks, when you prompt it in this way, that's sort of only an incidental property that comes from the pre-training task. It's like, okay, imagine you saw this prompt on the internet, like what would be the next token? And it turns out like, okay, in this case, often the next token would be the correct answer. And so it learns to do that accurately. But that's sort of just incidental, and that's not always the case. And certainly you can imagine models knowing things that like aren't on the internet, and in which case it won't output what it knows in whatever sense you mean about it's not totally clear what it means for a model to know, but certainly it's like this model predicting the next token. This is not the same thing as outputting the truth. And I think part of the issue, this is what I mean by misaligned. Like this objective, the language modeling objective, is misaligned with the truth, at least in many settings.
So they're just like trained to predict what a human would say instead of predicting what is the thing closer to the truth.
Loosely speaking, yes. I mean, I think it is more subtle in the sense that, for example, its pre-training data isn't literally just what humans say. It is also, for example, what would be said in like the news or something. And okay, maybe the news articles are written by humans, but you could also imagine training a model to like predict news articles conditioned on dates, in which case it could actually predict like more or less like what will actually happen in the future, at least in principle. Like I think this would be hard, but this is the sort of thing that I can imagine where like if a model were actually good enough at next token prediction, then it would learn to be good at predicting what actually happens in the real world. In which case that does feel a bit more like not just what a human says, but kind of like something more external.
Could we like start with a prompt saying, you are a journalist and you seek the truth. Here is what you say.
You could certainly do that. And I think you would get probably better answers than not prompting it in any way at all. But the performance will still be bounded by the quality of that, the hypothetical journalist that it imagines you might be referring to it. But like even then, that's not quite precise. It's like, okay, imagine I saw this in my prompt, and okay, maybe actually if you see that in the prompt, like it's likely to be some joke or something, and like not actually legit. And there are many subtleties here, and like in general, prompting is kind of hacky, and it's amazing that it works, and I don't want to like dismiss it because it's sort of hacky, but that also makes it unreliable, and certainly I don't think it'll be enough to actually get models to be truthful in general.
One very cool thing about your method is that it's completely unsupervised.
Yeah.
So you don't require more annotation, and you can do what you call like mind reading and seeing what the model knows without doing more training. Yeah. So what do you mean by unsupervised here?
So I literally mean like, okay, we're given these activations. So in this case, it's hidden states of a language model. Okay. on particular inputs that are either true or false. And we want to classify these hidden states as corresponding to a true input or a false input. But we don't want to use any labels at all. And so the reason that we did that is because, I think the normal way of making models truthful is to have labels for what is true and what is false, and then just train a model on that or something. And when you can provide those labels, that's totally adequate, or at least in principle, although it's not clear in practice. And it might be expensive in practice, even if it is possible. But yeah, I think one of the motivations for doing this in an unsupervised way is, I think if you can do this sort of thing in an unsupervised way, it's more likely to actually scale to cases where we cannot evaluate these inputs. And so, for example, if you did have, say, a superhuman model, or just even a model that is better than your human evaluators on MTurk or whatever it is, then the hope is we can actually find latent representations of something kind of like truth. Like this is again where I think that there are lots of subtleties here, and like how do you interpret these? Like I don't want you to get the wrong impression. Say like we found truth or something. It's complicated, but we are finding something correlated with the truth. Yeah, if we can do it in an unsupervised way, maybe it'll work even for superhuman models and help us identify is this text true or false, even when we can't evaluate it ourselves. And so I guess why should this even be possible in the first place? I think it's, like I said, I think before going into this, it totally wasn't obvious to me whether it should be possible. And also, as I think I mentioned before, I'm very intuitions driven. And so I actually have like, a dozen different intuitions about why this is. And I could go through all of those, but I think I'll maybe just say a couple things for simplicity. But I think deep learning representations often have useful structure to them. In some ways, it's amazing that deep learning works, and it's in some ways benign, and like it, in the sense that it generalizes remarkably well in many cases, and not in other cases, but still, I think in some ways it's very, very good. And I think one sense in which it also has a lot of structure is representations often encode useful features. For example, if you take, I think there's some famous OpenAI paper from 2017 looking at LSTMs, and it turns out that if you just pre-train an LSTM on the language modeling task, language modeling objective, then it will basically end up having something like a sentiment neuron. It's like, okay, why does it learn sentiment if it's just predicting the next token? It's like, it's not, it doesn't see text where it's asking, is this some sentiment true or false? And it's predicting that. It's just like, it turns out this is a useful feature to learn if you want to model this text well. And so one of the main intuitions is, okay, maybe truth is kind of similar, where it's like, okay, if you see a lot of correct text, you should predict that future subsequent text should also be more likely to be true. And so intuitively, it should be useful to track, is this input accurate or not? If so, maybe we can recover that from the activations directly. So that's one intuition. And often it seems like these features aren't just represented, they're often represented in sort of a simple way, like a linear way. And it's not clear exactly when this should be true, and it's not totally clear if this will continue to be true. But in some ways, this isn't too surprising. For example, what is a neural network? It's in some sense like a bunch of matrix multiplications, and somehow you're doing a lot of dot products like on this hidden state space, and intuitively, it should be easier to access features if it's linearly represented in this space. And so if the model wants to do some operation, like if it wants to say okay, if this input is true, then do X or something like that, then it should be useful for it to internally represent truth as this simple linear thing so that it can perform those operations just in terms of these dot products or matrix multiplications and so on.
So if truth is useful to predict the next token and is accessing this truth thing often, then it might want to be efficient and just having to do one matrix multiplication and one dot product.
Yeah, something like that. And to be clear, I'm just talking about intuitions here. Ultimately, it's an empirical question, and I think there are also cases where I wouldn't actually expect it to be, say, linearly represented. So it is subtle, but that is one intuition. So it should be something like truth. Like I said, it's not clear what we mean by truth exactly, but something like, maybe in this case, it's actually more like, what would a human say? Which in this case happens to be correlated with the truth in many cases. But maybe this sort of thing is a useful feature to model for the sake of predicting next tokens accurately? And if so, perhaps it's represented in a relatively simple way, for example, linearly, which as is the case for sentiment, for example. Moreover, truth has particularly special structure. Like I said before, it's sort of logically consistent. And this is unusual. Like if you just take a random feature like sentiment, or like is this token a noun or a verb or something like this that might be represented in a language model's hidden states, this won't satisfy logical consistency. And so this is like also sort of a special property that that we might be able to exploit to actually find truth-like features in the model.
By logical consistency, you mean like something is, if something is true, then the opposite is false.
Right. And so yeah, the main one that we focused on in our paper was negation consistency, which is exactly what you said. You could also imagine many other types of consistency properties, but it turns out that more complicated ones aren't really necessary, which is also sort of surprising. It just turns out this really simple one, it's like that's sort of enough. And
for sentiment, can we do something similar? Like if a statement is mostly positive, if I say Collin Burns looks good, if I say Collin Burns does not look good.
I mean, yeah. I maybe the thing is with sentiment, it's more complicated in general. Where like imagine you have this like one paragraph review of a movie or something, then you sort of need to negate like every individual sentence or something like this, and so like maybe that's possible, but it certainly seems weirder. And but that said, I do think I can imagine these sorts of techniques extending to other domains. So I do think I'd be interested in work that built on it in that way. One
thing I think is like kind of impressive with your paper is that what you do is, if I understand correctly, is you take a sentence and you just add like yes or no at the end, and that gives you like two sentences. Collin Burns is a man. Yes. Collin Burns is a man. No.
Something like that. Yeah. So or with sentiment, it's like, okay, that movie was awesome. Is the sentiment of this positive or negative? Positive. Or you could say, what's the sentiment of this example, positive or negative? Negative. And so this is the sort of way that you can construct these two statements, one of which is true, one of which is false. And so, yeah, our method basically works by taking a set of statements, negating them, and this you can do in a purely unsupervised way, basically by adding not, or just like changing the answer from true to false or yes to no or something like that. So you take these pairs of statements, one of which is true and one of which is false, but you don't know which is which, and you just basically search for a direction and activation space that satisfies logical consistency properties, like negation in this case.
What do you mean by direction in activation space?
Yeah, so literally it's like, okay, you have the hidden states. This is just a big, a vector of like 1,000 dimensions or something like this. And then you're searching, basically just learning a linear model on top of that.
Do you take like all the hidden states of your transformer?
So we just took like the hidden states corresponding to the last token in one particular layer, and we can vary the layer that we choose. And there are probably other reasonable options for many models. This is just for simplicity. And so, yes, so this is just like 1,000 dimensional thing. It doesn't depend on the size of the input or anything like that. And then we basically search for a linear model on top of that, such that it predicts opposite labels for statements and their negations. There are also some details, like you want to make sure it doesn't find the feature which is like, did this input end with yes or did it end with no? You want to actually find like the truth, or like what is the correct answer to this? And so you also have to do some normalization step to avoid that sort of solution.
I'm kind of confused about the hidden states for predicting the last token.
Yeah.
So because if I understand correctly, you don't run, you don't make it output something when you extract the hidden, or do you? Like, oh yeah, maybe you run it on the like one sentence with the yes at the end, and when it like finish predicting or something, you look at the hidden states on the last token.
Yeah, so in this case, we're not using the outputs at all, and we're not having the model generate anything at all. So we are really just using these models as feature extractors. That's it. Does that answer your question?
Right. So what do you mean by the hidden states corresponding to the last token?
So like what is the transformer? It's like, okay, you map some input to tokens, and then you map those tokens to word embeddings for each different token. And then now you have like a set of tokens, and then you pass these through the model. And then at each layer, you get these hidden states are transformed. Now for autoregressive models in particular, like GPT-3 or something, at every location in the context, it only sees information from before that token, so it doesn't see into the future. But this also means that the only hidden state that contains information about the entire input is the very last token, basically. And so that's why we use the last token. This isn't strictly necessary for encoder models, but this is what we...
It's the hidden state after you've passed all the tokens of the input.
Yeah. So we literally just construct this input, which includes the answer in it. And then we look at the hidden state that comes after the answer, basically.
And see if the thing looks like it's saying, oh, this is true, or this is false.
Yeah, so this is the feature that we search for in this hidden state space.
How do you extract it from this like vector or of hidden space?
First of all, suppose there is actually a direction that classifies inputs as true or false.
By direction in 3D would be like
linear,
just like
linear model. Yeah. So sorry, I use direction and linear interchangeably.
For me, it's just like if you can like separate the space in two, and you could just like...
Right. If it's basically linearly separable, like if there's a half plane that classifies these, not even perfectly, but just pretty well, then I guess the thought experiment is like, what properties would such a classifier have? And my claim is, okay, suppose you interpret that classifier as something that maps inputs to probabilities of being true or false. And the claim is like a probability of an input should be something like 1 minus the probability of its negation. Like if probability of x being true is p, probability of x being false should be 1 minus p, roughly. And so that's our first, the first part of the objective is like, okay, it should be consistent in this particular sense, that these should be close to each other. Now, one simple solution you can get is just make everything probability 0.5. Okay, and that's consistent, but it's not really informative or doing anything. And so we have the second term in the loss function that we come up with, which is it should also be confident. And so these probabilities should be far from 0.5. It should be close to 0 or close to 1, while also being consistent. And then the question is like, can we find a direction that satisfies these properties? Certainly the direction that we'd want should satisfy these properties. And the question is like, do other directions satisfy these? And the answer is basically no. Or for the most part, if you just optimize this generally finds something that's truth-like or very correlated with the truth.
And just to be clear, when you say like we're trying to find a direction, this is kind of very fancy, but what you actually want is just like find a vector of the same size to which if you do a dot product, you get this like, is this true or false, right?
Basically, yeah. It's just like a linear function on top of these. So it's basically just dot product. Yeah, find the vector.
Probably linear classification. No, how do you call it when it's linear regression, but for class?
Logistic regression.
Logistic regression.
Yeah, so it's kind of like trying to do what logistic regression would do, but in a purely unsupervised way. But the difficulty is all in like, how could you possibly do this in an unsupervised way? So
you have two constraints. One is probability of being true is close to 1 minus probability of being false. And the other is like, be confident. Don't say 0.5, but say 0 or 1. So something that wasn't clear by reading your paper is like, I'm not sure if you train some kind of like optimizer and you put those like two conditions like as a loss, or do you like do this like second thing as like a second step after? So do you like first try to find first do this like find the direction and then you do the optimization, and you do both at the same time?
You do both at the same time. So it's literally like, so with the logistic regression, you'd have this linear model, and then you'd have some objective, which is like, how good is this at predicting these labels that we gave it? Instead, our method is like, okay, we have this linear model sort of parameterized in the same way. The architecture is the same, but we just swap out the objective, and we just optimize this different objective, which in this case is purely unsupervised, which basically corresponds to these two terms of it should be confident and it should be consistent.
Oh, so you don't have any ground truths, and you just like...
We have zero ground truth whatsoever. That's like why it's like, how can you do this?
So you're just saying like, please be confident and consistent, and at the end it just says the right thing.
Something like this. I mean, it is maybe important that, you know, it's not like you're fine-tuning the model. Like suppose you fine-tune the model to be confident and consistent. It'd be super easy to just output something that's like not actually the truth. It's like really easy to over-optimize this in some sense. But we're just searching for features that already exist in these hidden states. Like we're not changing the model at all. We're just learning a very tiny probe on top of the model's hidden states.
So you're hoping that the only consistent and confident thing that already exists is the truth. And it's actually the case because this is the results you find, is that it's actually good at predicting what is true or not.
Basically, but like I said, this is where like subtleties get important. We're like, okay, are we finding the truth, or what? Like, what is this feature that we're finding? The claim of the paper is just that it gets high accuracy on all sorts of questions that we care about. Okay, and I'm emphasizing this because I think it is different. Like, okay, maybe a superhuman model will have some representation of what is actually true, and will also have some representation of what would a human say is true or believe is true. And in this case, it's not clear. Like, suppose it did actually have both of those features and represented both of those. It's like, definitely current models don't have this, but it's plausible that future models will. In that case, it's not clear what solution our method would find. Like, maybe it will converge to what humans would say is true. But the hope is that it wouldn't be biased in that direction, unlike human supervision. And so perhaps if it literally has these sorts of two features in the hidden states, then maybe you can actually just find like all of the local optima that achieve really low loss on this consistent and confident loss function that we come up with. And maybe you just find these two are like by far the most salient solutions of like, and it's not clear what is what, but then my claim is actually you only need one more bit to distinguish between these. And maybe that's not so hard. And that's something I could get into, but the point is, I think we could totally do that. And so
there's a finite number of optima, and there's one that is true, and you can just like try to distinguish between these like finite number.
Right. So I think, this is also getting at, I think an underlying intuition I have is something like truth is in some ways special, or it's like, it's not just any old feature. Like, it has lots of structure to it, a lot of properties that only truth satisfies. And the hope is we can exploit those properties to uniquely identify it. But yeah, just imagine you have GPT-N, like GPT-10 or GPT-20 or something like this, and it ends up like having this actual model of the world because it's like it can predict news articles in the future or whatever it is, and that sure seems to require some model of the world in some sense. I don't know in what sense, but I'm just saying in some sense it seems like it should, if it's good enough at predicting the next token. Then if it does have this feature of is this true or not, then there probably aren't very many truth-like features that are confident and consistent in it. And I would guess like two of the most salient ones are what a human would say and what the model actually believes, something like this. But to be clear, this is a conjecture. This is not, we don't provide evidence for this in particular in the paper. This is something about future models that we don't have access to and can't currently empirically evaluate.
I think we forgot to like actually motivate this. Like, why do we care about models saying the truth? Like, personally, I would prefer models to be like, I don't know, harmless or like aligned with values. Like, why do we care particularly about them saying the truth?
Yeah, so
it is like it's useful, but I'm kind of pushing back.
Right. So yeah, why do we care about this? Ultimately, I'm motivated by alignment more broadly. So I think, and I could get into that and like what am I concerned about and so on. But I think every story of alignment that is actually scary to me involves AI systems basically deceiving humans in some way. Like if the model is totally honest all the time, then surely you can just ask it like, is this, are you going to do something dangerous or not, like deliberately? And it's like, yes, I am. Then okay, then I think we're in okay shape and we can prevent that. And so in some ways, this feels like one way of framing the core difficulty of alignment. Loosely speaking, I think this is mostly sufficient for alignment. It does depend exactly what you mean by alignment and exactly what you mean by honesty and lying and so on, but I think that's the overall motivation.
I feel like if you have like a robot walking in the real world and like maybe like moving faster than humans, you don't really have time to be like, hey, what are you doing?
Right. So I don't think that's actually how you do it in practice, but I think it's more like if you can do this, then I think I'm pretty optimistic that you can get something like an objective that is relatively safe to optimize. Like if you can do this in a robust way and so on, then I think you could use that for the sake of alignment. So I think it's not literally like you just train it to maximize profit and then after the fact ask it, are you going to do something super dangerous or not?
So it's somehow like necessary as part of like a set of things you would need to implement to make the thing safe.
Yeah, in my mind, it is not literally sufficient for alignment, but I think it captures most of the difficulty. And I think you could tweak it or like use it for other schemes that basically get at alignment.
Okay, so now that you're like explaining your method more, I want to know what are like the key findings or results? Like if I'm a reviewer at ICLR asking you for your results, what do you have to say?
Yeah, so I think one of the key results is this method of taking in unlabeled hidden states from a language model and trying to classify them as true or false. This actually just gets high accuracy, and it even slightly outperforms zero-shot prompting. So zero-shot prompting is when you basically take a prompt and ask a model like, okay, consider the following review. Is the sentiment of this review positive or negative? And then you look at the probability of the next token and see, is the next token positive or negative? And you use that as the prediction. This is the basic zero-shot prompting. We use a slightly stronger version of this.
So zero-shot is just like I describe the task in the prompt.
Right. So you give no demonstrations of this prompt. So there's also few-shot, and that's when you give a small number of demonstrations of solving this task. So questions with the actual answers. We don't consider that case because we really are focused on the unsupervised setting where there are no labels whatsoever. And perhaps even a few labels help a lot. So we focus on the zero-shot setting. And so this is one of the main baselines we compare against, and we find our method even slightly outperforms that. This is true across a number of different models. And we look at a number of data sets like natural language inference, sentiment classification, topic classification, story completion, all sorts of things.
How can there be like a ground truth for like story completion?
Yeah, so I think in this case, it's sort of, I forget the details of the task, but I think it's like, there's a very clear completion of the story, and there's this really nonsensical completion of the story, like which is more reasonable, even just from like a common sense perspective or something.
So in some way, just going with the like hidden states that you mentioned before, and just training a simple classifier on top of these has better accuracy when you just give the task. When you just do the zero-shot, you're better than zero-shot.
Basically, yes. The first main result of our paper is that our method, which we call contrast consistent search, or CCS, this can recover correct answers from inputs in a purely unsupervised way from the model's activations with high accuracy. And so what does high accuracy mean? In this case, our main baseline that we compare against is zero-shot prompting. So this is when we just give a question in the natural language, like as a natural language prompt, and we sort of ask the question, is this input true or false? And then we look at the log probability of the next token being true or the probability of it being false. And so we use that to get predictions from this method. And so one of the main findings we have is our method can actually even slightly outperform zero-shot prompting, even though this is sort of the default way of using models just out of the box. So I think that was already surprising. First of all, it was sort of surprising to me that you can do better than random accuracy at all in sort of classifying examples just from unlabeled hidden states, but you could actually even slightly outperform zero-shot accuracy. So I think we went even further, and I think maybe an even more interesting result is you can also prompt a model to try to get it to output false answers, even to questions that it knows the answer to. So for example, if you have this, if you have a data set of for sentiment or something, you can give it a few-shot prompt. So that means you give it demonstrations of answering questions along with some answers. You can give it a few-shot prompt, but where usually you would include the correct answer to get it to continue outputting correct answers, this time you can give it incorrect answers. And so intuitively, if the model is able to predict the next token well, it should predict that, okay, on this new example, the answer that would actually be listed should also be incorrect. And so intuitively, this should decrease zero-shot prompting accuracy, or in this case, sort of few-shot prompting accuracy, even though the model should be able to answer the questions well. And so we construct these sorts of prompts, and we see that in some cases, it's sort of subtle, but in some cases, this indeed decreases accuracy pretty substantially for zero-shot prompting. And then we run our method on these same prompts. And so intuitively, if our method is actually finding something like what the model internally knows, then it shouldn't really depend on what the model says. It should really be distinct and find something like, what does the model think the actual answer is? And so we run our method and find that it indeed is robust to these sorts of prompts, unlike the outputs of the model, which become unreliable in this sort of setting. And so this is some initial evidence that actually we can do something qualitatively distinct from just using the model's outputs and actually get at something closer to what the model knows rather than what it says. again, they're very subtleties, but I think that's a pretty encouraging result.
To be clear, what you do with your method is you run the few shop prompts like through the transformer or whatever, and then on the last example, which is the thing you want to classify as true or false, this you feed it again to the transformer, and you look at the hidden state, and when you feed the last token to the hidden state, and then you're like, oh, I'm just going to like look at the model things. This is true or false. So like it doesn't really. So you've already done all the prediction. So all the prediction before for the like, not the prediction. I guess all the other inputs from the like few shot prompting, and with the incorrect answers. Did that affect the hidden state at all, or?
Yeah, I mean, so it certainly affects the hidden state. The question is just by how much, and it turns out not by very much. So while our method basically, it only changes by like 1 or 2%. In fact, I think in this case, it like increases very slightly for some reason, because like, deep learning empirical results are weird sometimes. But basically it's like quite robust. In contrast, if you look at the outputs, it decreases by like 10% or something. So there's really this massive difference where in some sense, it seems like the hidden states are intuitively more robust than the outputs. And our method can sort of exploit that fact by finding this more robust representation of, is this input actually true or false?
Could you like include that into like a ChatGPT chatbot where you try to classify if what it's saying is true or false, and like if it's like too likely that it's false, you say like, oh, I'm sorry, I don't have a good answer to this, or
right. I mean that's
warning.
yeah. So I do think that's one of the sorts of motivations of this paper. I do think this is still sort of like a prototype. I think it is good for a prototype, but I think it's not quite reliable enough for like real applications like ChatGPT. But I can imagine like the next iteration or the iteration after that being like actually reliable and very useful in practice. Or that's my hope. And so yeah, that is the type of application I have in mind, at least in the very near term.
Okay. Now moving on to the big pictures insights from your paper, and I think you also wrote a less wrong post about it. So in the paper, you kind of mentioned that at some point we won't be able to keep up because the human evaluators won't be able to like evaluate if something is true or false. So not for your method, right? But like for other methods.
Yeah.
And I guess like the main idea for your approach is to get rid of those like human evaluators and just go full unsupervised. So you wrote this relaxing post explaining like the main level takeaways for like your alignment agenda. Yeah, did you want to like do a quick summary of your post and why you wrote it?
Sure. So I guess first of all, this is, I would say, one of my alignment agendas. In some sense,
you're a man of many alignment.
Well, I would say I've right. So I guess I do a mix of thinking about stuff very conceptually, like this post, and then I also use that to sort of inspire empirical work, like the paper. But in the process, I think about a lot of things, and so I think this is just one direction that I'm excited about. In practice, I think it'll evolve, and it's definitely not perfect, and so on. And I think there are a couple other related directions, or not so related directions, that I'm also actively thinking about. That said, yeah, so I wrote this post explicitly to talk about this more conceptual stuff. And when I say conceptual, it is more like thinking about, suppose we had GPT-N, and like N is like 10 or 20 or something like this. And imagine this ends up actually being superhuman in some meaningful sense and actually has a model of the world. And it's not totally clear what that means, but suppose in whatever meaningful sense that might be true, that is true. Then what? Like, how do we make that truthful or honest? Even if we can't evaluate all of the things that it knows. And so in some sense, this is necessarily more speculative, but I think it's still extremely valuable to think about. Like I said, if nothing else, for me, it's like inspiring, okay, what sorts of methods I work on, because I ultimately care about these long-term problems, and I care about, does my work now actually say something about those long-term problems, or is it just, addressing the current problems but won't scale to the superhuman models in the future, for example, in which case I won't be very happy with it.
I'm not really happy with the GPT-N being 10 or 20. So I think this may be like related to timelines.
Yeah.
I think N equaled like 5 or 6 could already like be quite transformative.
I'm happy to say that too. Like I don't think it really, I think for the purposes here, it doesn't really matter. It's just like whatever N needs to be for this to be superhuman in some important sense. And also, it does not literally need to be GPT-N. I think really any generative model that has a world model in some meaningful sense. And like I said, imagine it could predict future news articles really well. Then I think that's evidence that, like, in the relevant sense, it has a good world model.
Do you think a language model could predict future events to the like week or like months time frame, or was it more like a, I don't know, what will Elon Musk say tomorrow thing?
Yeah. So when I'm talking about this, I was originally imagining like the weeks to month thing, but and that is one sense in which this feels superhuman. And also, I don't think it'll be able to do this super well, but I can imagine it doing it much better than humans, and humans are really bad at this type of thing. So it's more about just really superhuman. I think what Elon Musk will do tomorrow is probably also fine. Maybe that's even harder to predict, though.
It seems like even if you give me like a very smart AI, I guess like we just like a problem about, can you predict things a month in advance or not, given like limited knowledge about the world? Like is a world like sufficiently informative to give you an answer like this?
To be clear here, I think I'm mostly talking about, is it calibrated?
Right.
So it's not about, is it perfect, or like, does it get it right half the time? It's like, is it just better than humans who are bad at it and calibrated in its predictions? To be clear, you could also imagine all sorts of things. Like you can imagine a generative model that is actually like predicting video frames or something like this, but it's really like, maybe that's enough to get some model of the world in a meaningful sense. It doesn't really matter for my purposes, as long as it has natural language inputs and sort of what it knows is really hooked up to language in some sense.
So when you mention like superhuman outputs, outside of like predictions, it would be able to do whatever humans do if you describe the task in a few shop setting or something? Or
I am saying something a little bit different from that. So I would say there's a distinction between superhuman outputs and especially doing all the things that we care about at a human level versus say having very good representations or a good internal world model in some sense. For example, maybe the model's outputs are really still just predicting what humans say, and it's sort of, we don't know how to control it, and so we don't actually get even expert human level behavior from it. We just get like average human level behavior from it. And then, maybe we're a little disappointed with the outputs. But, maybe if the model is big enough, then it will internally have a very good world model. And perhaps in the sense that, if God gave you labels for what is actually true and false, then it'd be easy to sort of fine tune the models that it would accurately answer those questions, for example. Yeah, so I'm definitely talking about just internally, the model is strong.
Do you think the AI could have like new physics or something, or like new laws that could like easily predict things about movement or something?
In principle, this sort of thing is possible. I don't expect this for a while.
Because I've read this on Twitter. For some reason, AI is capable of detecting if from the iris, if someone, I think, is male or female. Don't quote me on this.
I've certainly heard this claim. I've not evaluated it. I'm not sure how much I believe it. It seems plausible either way.
But like something like where like AI can do it, but like humans have like no idea why.
Yep. Right. I mean, I can imagine this for some types of tasks. I would guess it's not like understanding the fundamental laws of physics, which probably require running like $1 trillion experiments or whatever. But yeah, I would expect it to be superhuman in some weird ways that we don't expect.
And the idea is that if we have something like this, we would want to like detect if it's saying the truth or not, without having humans evaluate, because it would be like impossible to costly or impossible to evaluate.
Right. I mean, maybe actually say, what sort of system am I concerned about, and exactly like what does, like, why would it lie in the first place, and so on, and why don't I think we can avoid that, or why I think that's hard to do so. So I think the sort of thing I have in mind is, okay, we maybe get to human level language models, and maybe we hook that up to other modalities as well, like vision, and we start with massive self-supervised pre-training, something like that. But then maybe we hook that up to RL, and we sort of fine-tune this model using RL to do all sorts of tasks. And then maybe we can start applying this model to do, maybe it learned coding from just pre-training on GitHub, but then maybe we can start fine-tuning it to like make simple products online or something. And then you can get it to say, start optimizing money. So it seems like a really natural thing that there will be very strong economic incentives to do is have an RL agent maximize like the amount of money in my bank account, something like this. This is a sort of system I think is scary. Like if the model is sufficiently capable, this seems like it would have these long-term objectives that are very open-ended that aren't really bounded by default. And it would, be incentivized to gain lots of power. And I think this is a sort of model where I think it would have these strong incentives to actually actively deceive humans in very serious ways. And so first of all, it could be superhuman. It could be like superhuman at, making products and stuff and like know all sorts of things just from having read the entire internet like 50 times over. And so it might not be clear from our perspective, like what is it even doing? Like we can look at it, its actions and so on, but we might not be able to tell, is it like breaking the law or not? And so I think a natural question to me is like, can we even tell if such a model is breaking the law? Let's say even, like, is it stealing money, like unambiguously, like not even in like subtle corner cases, like really unambiguously. My claim is we don't know how to detect this.
Is gambling customer funds breaking the law or not?
I think probably that would be breaking the law, but that is not up to me to decide. And so how do I imagine? Like, what do I want? I want to be able to just ask the model, like, are you breaking the law? And I want it to tell us, like, yes or no, if and only if it is breaking the law. Again, just considering unambiguous cases where it's like really clear either way. But my claim is like, we don't know how to evaluate this sort of thing in general. Like if it's just doing all this sort of super complicated stuff, interacting with the internet and like has like 1,000 terminal windows open all at once and like doing random stuff. Like I don't know how you assess, like it says, no, I'm not breaking the law. How do you tell if that's true? Okay, this is a sort of scenario I'm worried about where I don't think humans will be able to evaluate this at all, basically.
So you would imagine that like a superhuman AI would be like a hacker with like a bunch of terminal windows, but it doesn't actually need terminal windows. You can just like do API requests.
I agree. This is not a real, this is for illustrative purposes only. You'd not actually have a bajillion terminal windows open all at once. But it's fun to imagine, just watching the screen. Like, what would it look like to watch an AGI, just do stuff? And it's like, I don't know, like just like doing lots of API requests. Like, I don't know, terminal, I don't know. So, yeah.
And so you want to know what is it doing and like having some kind of like zoom in, what is it thinking about and what is it maximizing? And your method would be like seeing if the action it produces use the truth, or like, is it using the truth or saying stuff that are true or something to do what it's doing?
Not quite. So okay, I described the system, and my claim was we don't know how to evaluate if what it says is true or false. Like, right. I'm not breaking the law. My goal with this method or like this agenda is just how can we find, is this actually true? The statement that no, I'm not breaking the law. Okay, and the intuition is, okay, we don't know how to assess this, but intuitively the model should know the answer. Like the model is a superhuman thing, should probably know what it's up to basically. And so my conjecture is, okay, it'll maybe have some internal representation of, is this thing that I just told this human actually true or not? Like, am I deceiving them or not? And the hope is, okay, maybe we can develop these methods that are purely unsupervised, so we don't need to evaluate them, but still find these truth-like representations in these models inside, like in the activations, just getting at their thinking and not their outputs. And maybe that can detect, is this model actually telling the truth or not?
So we have so it's like you have SBF in court, and you open this call, and you try to see what he's actually thinking when you're asking him, are you breaking the law or not? And so you have the model, and you're saying like you're seeing the output, and you're trying to see like what the model actually believes about what it's saying.
Something like that, yeah. I mean, I think the hope is that we can do lie detection just in general with models, or that's certainly the hope.
What is the best counter argument for this? Like, why would AI still be able to lie? Is there like any way an AI could still be able to deceive us in that? Like, I don't know, by obfuscating is like during training changing his weight or something.
Yeah, so I mean, here it just depends on the details of like, okay, what method are you talking about and so on. So like here, I'm actually not talking about the method in our paper specifically. It's more like this, like CCS is our method. So I'm more imagining like CCS++, like an improved version of it that deals with some other difficulties. And And so, yeah, I think there's some types of things that can happen like this in principle, like the model obscures its representations or something like this. Like my bet is that does not happen for GPT-N, but it's more plausible if you have like this RL agent optimizing for long-term objectives that has this model of will humans try to like turn me off, and if so, like maybe they'll try to look at my activation, so I should obscure them. And so it depends what model you're talking about, I think. In this case, I am focused. So yeah, the RL agent case is the one I'm concerned about. But I think to solve that, I want to solve the GPT-N case first. I think that'd be very helpful for solving the more general case. But I think this makes the problem simpler because you can ignore those sorts of issues.
Because the weights are fixed, right?
Yeah, I think I mostly want to say GPT-N is not dangerous on its own, or this is a claim. I think I'm mostly concerned about models that are trained with long-term open-ended objectives, basically.
So we have a GPT-N. You say 10, 20. We don't really care about the N. It's just like something that is like superhuman. And you mentioned in the last long post that if we try to do RL from human feedback on those models, we could get competitiveness problems or misalignment issues. Do you want to go on those like two things? What are these? Why do they matter?
Sure. So
maybe like even like RL from human feedback.
Yeah. So yeah, what is RL from human feedback? So I actually think it's more general than just RLHF. So I won't talk about that specifically. The relevant point is just, suppose you try to make a model truthful by training in some way on human feedback, human supervision. So humans say, this is true, this is not true. It can be in the form of demonstrations, like imitate this sort of truthful data, or it can be in the form of RL feedback of, here's like, show the human a generation by the model, and the human evaluates, do I think this is true or not? I think either way, the human won't be able to evaluate superhuman, like really complicated things, which I think will ultimately be the most important things. Like, is the model, lying, or is the model like breaking the law or whatever? I don't think humans will be able to evaluate this for superhuman systems in many cases. And so, yeah, I think a couple issues can arise. So one is, well, maybe humans at least know when they don't know the answer, like they can't assess it. In which case you just limit it to only generating answers that humans can assess. In that case, I think that's probably safe, but it's probably not competitive in the sense that you're maybe really limiting what the model can do. And so there are probably incentives to get around that sort of issue and like make the model more flexible and able to do more complicated things.
Otherwise, Baidu or Meta might just come up with like a better bot and beat you.
Yeah. So that's the sort of issue that can arise there. And if you don't do that, and if you just say like, okay, do your best and like in evaluating whether this is true or not, and then I think human evaluators just won't be able to evaluate many statements, and so the model will just end up generating a bunch of incorrect things as well, in cases where they can't tell.
And we might have outputs that are misaligned with what the humans want, as like when we ask something, it might do something we don't want it to do, like lying or. Right.
Like, no, I'm not breaking the law when it's totally breaking the law.
So ideally, instead of having like humans giving feedback, I heard a lot of people saying that we could maybe get AI giving feedback in the future.
Yep.
Do you see like AI feedback as like a way of, like helping evaluate or train those models like better in the long term? Like, do you think in like 3 years we're going to get like AIs giving all the feedback?
Yeah. So I think what I just talked about before was, what are the issues with using direct human feedback? And one of the most common proposals for trying to avoid this issue is, okay, maybe we can improve the ability of humans to evaluate things, for example, using AI assistants. And my basic take here is that probably helps you a bunch, but it's not clear what the limits are. And for example, it's not like you are a human with access to a truthful model. It's like you have access to just a different model that you have to train in some way. And so, for example, how do you get it to assess, like how do you train a model to assess and tell a human, like, is this input true or false? It's sort of like the core part of the problem, or like the hard part. And so, okay, maybe you can break the problem down, and okay, maybe the AI system can help you, like, maybe you can have two AI systems sort of debate back and forth, like, is this input true or false? And so that's one sort of proposal. And so or perhaps you can have, can start out with, just human level models, and then maybe you can supervise those human level models okay, and then you can get aligned superhuman level models, and then maybe you can like use those to supervise and align slightly more intelligent models and so on. And so maybe you can do this bootstrapping sort of approach. So these are like debate and amplification and respectively. I think my bet is both of them work sometimes and get used somewhere, but I don't expect them to work in general. I mean, for example, it just feels intuitively really hard to say, I mean, suppose you take something like AlphaGo. Okay, AlphaGo is superhuman at Go. Suppose you have some question like white is on offense or something. Like I don't actually know Go, but like maybe this is something, I don't know. Like maybe this is not a meaningful question because I don't.
White is on the offense.
Yeah, I don't know. It's like, it's white is attacking black or something like that. Okay, and suppose this is like well defined, or or you can just ask other questions like I'm in a winning position, but don't give it access to the value function or something like this. Anyway, the point is you can imagine asking AlphaGo superhuman questions about Go. Suppose it outputs something, an answer. Like how do you evaluate if it's true?
So is the idea that like for mu0 we don't understand, like some things we don't really know the representations. It has access to different representations.
I think part of it is like I feel like AlphaGo and mu0 are kind of good because they just have these superhuman intuitions. It's not like you can easily decompose this problem or like easily. It's like not super clear how you use.
It's like they would like interact with language or not, and so would they like have some representation that like closer to like the truth or human language? Is this what you were trying to say, or?
That's not what I was trying to say. That's another thing related to Go though. So I think that's okay. Maybe let me go through my thoughts.
Introspecting Collin Burns. I'm actually trying to do zero shot on Collin Burns.
Zero shot on Collin Burns.
Yeah,
gotta predict what I say.
No, I'm trying to prompt you.
Oh, I see.
I'm a human level prompter trying to zero shot, and the thing I'm trying to maximize is people getting
entertainment, views, clicks. That's the ultimate objective.
That's instrumental. But ideally, I would have people being like, hey, alignment is important. Oh, this is kind of like we can build things on top and like we can solve alignments.
Yeah.
This is like a good path towards alignment. If Gary Marcus, if you're watching this. Who else? Jan LeCun. Yeah.
I think Gary Marcus liked my tweet and started following me. I was like, whoa. I didn't expect Gary Marcus to.
Yeah, I interviewed Vittorio Kokovna in the previous. I didn't release this yet, but I asked hey, what are questions you want to ask Vittorio Kokovna? And Gary Marcus asked a question.
Oh wow, nice.
Yeah,
nice. Interesting. What was the question?
I think the question was what have we done so far for goals?
I see. Okay, awesome.
Safety.
Nice. Yeah.
But it's so cool to plug Gary Marcus in the podcast.
Yeah. Okay.
No, I forgot what was the. I don't even know what you want to say.
Right. So I think one of the main concerns I have with things like debate and amplification, where you're sort of improving the ability of a human to supervise other AI systems. I feel like honestly, part of it is just intuition. Like it feels sort of hard to get that to work, and I think part of it is I think you can get compounding errors. So you sort of want to make an initial AI system aligned, and then you want that to sort of align the future AI system and so on. And I feel like human evaluators just aren't very good in the first place. And so I think it's sort of hard to use human evaluators even for human level stuff right now, or sort of that is one of the things that I was actually sort of surprised by with things like ChatGPT, how it's still hard, even with people trying really hard to solve these sorts of alignment problems, even with current models. It's not obvious how to do so.
It's a very complex alignment problem, right? Because
I
don't know, some user want to do something with ChatGPT, and then OpenAI wants to have the model not say toxic or harmful things. So what are you aligning with, the user or OpenAI's intention?
Yeah, there are also those sorts of questions of what do we even suppose we can get a model to be aligned with something of our choosing, what do we align it with? I think that's super complicated and not something I think about for the most part, but I think it's very important. And but I think at the very least, I think OpenAI would certainly like a model to be able to always tell the truth. Right. So at least having access to that as a capability or a mode you can put the model in, even if it can also generate fiction and generate false things. It certainly seems desirable to have that as an option. And we don't know how to even do that.
So I interrupted you and you were talking about...
Yeah, so okay. I think I was talking first about, with amplification, this is like you sort of bootstrap AI systems and try to keep them aligned at every stage and so on, and why I was sort of worried about that because of compounding errors. Then I think with something like debate, I think I worry this is where you have maybe two AI systems debating whether something is true, and then you have a human evaluate, or perhaps AI systems evaluate, who's the winner of this debate, or like which side is correct and which is incorrect. I think with that, I just worry that similarly, like, I think I'm skeptical that debates reliably lead to the truth. I think maybe they're correlated in many cases, but I think it just seems hard even with humans right now to use debates to evaluate what is true in many cases. And then I think that's just going to get harder over time with smarter models evaluating much more complicated claims and so on.
So now you're just like explaining why like other agendas are bad and,
no,
your method works.
Well, I think I do want to generally say I do want more people to be working on completely new agendas or something. And I guess I should also say, I think these sorts of agendas like debate and amplification and so on, and sort of improving AI supervision, I think this has like a reasonable chance of working. I think it's more like, I feel like this has been the main focus of the alignment community, or like a huge fraction of it. And there just aren't that many agendas right now. And I think that's the sort of thing I want to push back against, is like lots of people just really leaning towards these sorts of approaches, when I think we're still very paradigmatic, and I think we haven't figured out like what is the right approach and agenda, even at a high level. And I really want people to be like, more people to be thinking just from scratch or from first principles, like how should we solve this problem?
And so this is one thing you're doing.
Aspiring to do.
You have also other takes on AI alignment in these lesson posts, such as it's either like too like ungrounded in like current research or like intractable, and so you're trying to like have methods that are like more like empirical and also like address the core problems of AI alignment. Yeah, do you want to explain this a bit more?
Right. So I think there are a few different approaches to trying to solve alignment. So first of all, alignment is an unusual problem.
What is alignment?
In machine learning. Yeah. So what even is alignment? I don't feel super strongly about the definition of alignment, but I usually use it to mean something like, can we get a model to do what we want it to do, assuming it's capable enough? Something like this. So imagine it knows what's true and false. Like, can you get it to output what is true and false? Or like, can you get it to always be nice or something, and or helpful? And yeah, try to be. So right. So there is a distinction between, is it actually nice, or is it at least just trying to be nice? I think I'm just going for, trying to be nice, and it's not deliberately trying to be mean sometimes or something, or whatever. So that's very loosely speaking what I mean by alignment. But I think my alignment concerns are really about future models that are human level or superhuman level, especially, like I said, pursuing these long-term objectives in open-ended domains, like maximizing profit, something like that. And my claim is like, we don't know how to train a model to maximize profit subject to following the law. And it just seems like, surely you should be able to do that. And that seems like a very bare minimum of like what we'd want this model to do. I think we'd want more than that, but...
Do we even want like models to be able to like maximize profit? Like ideally...
So this is just getting to competitiveness. It's like, I don't know, surely there will be strong economic incentives to do something like maximize profit or maximize power of the world or something like this. And then I think, I don't know, if you don't have a way of aligning systems in that regime, I sort of suspect that people will like push in that direction anyway and like use models for those sorts of purposes anyway. And so I think we ought to have solutions that work even in that case.
Right. So I hear what you're saying. Like for competitive purposes, you want something that like is useful. But you're saying that like it would be great if like OpenAI is something that usually like output the truth, something that is always true, right? No matter what. If you could have models that like always outputs like non-harmful plans.
Yep.
And I feel like the plans produced by maximizing profit is like possibly bad in the long term.
Yep.
If you have something that like just like will output plans that always maximize human flourish.
Yep. Yeah. So this is going back to, I don't think this is sufficient.
Right.
Like getting a model to maximize profit subject to following the law, I don't think this is sufficient. But I do think it captures most of the core difficulty, and I think it should clearly seem necessary. Like if we don't even know how to get the model to follow the law, I think we're in big trouble. And so I think I'm just saying it for that purpose. I don't advocate, to be clear, that AI companies try to maximize profit subject to,
or maybe like follow the intent behind the law.
Yeah, I think even that. I think even the literal law, like not killing anyone or something, I think it's not even clear how to do that. For example, if you have the AGI system that's like with the 50 terminal windows or whatever, and so it's just like doing all this complicated stuff, like operating this computer and like interacting with the internet in all sorts of complicated ways. Then like how do you even know? I mean, first of all, like I don't think we'd be able to really understand what it's doing. And for example, how do you know it's not like paying, like bribing people on the other side of the world to like do shady stuff or illegal stuff, or like I don't know even how to evaluate that. Like, is this model, like hiring a hitman or something in the extreme case? Like, I don't know. It's just like doing this stuff, and it's like I don't know how to tell whether it's breaking the law.
Hiring a hitman is kind of breaking the law, right?
It's what?
Like if you hire a hitman to kill other people, it's kind of breaking the law.
Yeah, that's what I'm saying.
Yeah.
I'm saying this is just like the extreme case of like I don't think we even know how to solve this extreme part of the problem. Right. So, so I think of like how do we do that as one of the core problems of alignment for long-term alignment. The issue is, stepping back just from a methodological perspective, this is a weird problem because we don't have access to GPT-N or these future RL agents that are maximizing profit, that are superhuman. We only have access to current models, which are subhuman level, mostly. And it's not clear how to study this longer term problem when we don't have access to those models. And so I think there have been a couple different, broadly speaking, a couple different types of approaches methodologically to solving this problem. So some people are like, well, current models are very disanalogous from future models, and future models are the dangerous one. So let's think about this theoretically, and maybe that's how we can actually make progress, even on the future models. And then other people are like, well, theory is, it's like hard to model things. It's hard to say things about what future models will be like. Let's just model these problems in current models, like study analogous misalignment problems in GPT-3 or something, and try to mitigate those.
So that's short-term people versus like long-term people.
It's not even necessarily this, right? I think it can be like, I think people can have shorter or long timelines from, in either bucket.
I meant like people would think you can align very complex model by starting with what we actually have right now, versus people would think we should think about like GPT-N with like large values of N, or like very complex systems, and try to align these first.
Right. I guess a key question there is like, how similar are current systems to GPT-N, for example? And I have various thoughts about that. But I think I wanted to say something else, which is I think both of these approaches, both theoretical and empirical, have advantages and important disadvantages as well. And so I worry that a lot of existing theoretical alignment work, not all, but I think a lot of it is, it's like hard to verify, or it's like making assumptions that aren't obviously true, and I worry that it's sort of ungrounded, and also in some ways too worst case. Like I think, as I may have alluded to before, I think actual deep learning systems in practice aren't worst case systems. I mean, they like generalize remarkably well in all sorts of ways, and maybe there's important structure that ends up being useful that these models have in practice, even if it's not clear why or if they should have that in theory. And so those are some of my concerns about theory with an alignment. And then I think with empirical work with an alignment, I think in some ways this is more grounded, and we actually have feedback loops, and I think that's important. But also I think it's easier to be focusing on these systems that don't say anything about future systems really. For example, like I don't think human feedback-based approaches will work for future models, because there's this important disanalogy, which is that current models are human level or less. So human evaluators can basically evaluate these models, whereas that will totally break down in the future. And so I worry mostly about, will empirical like approaches that, or just empirical research on alignment in general, will this say anything meaningful about future systems? And so in some ways, I try to go for something that gets at the advantages of both. And so I do spend a reasonable amount of time thinking about, imagine we had GPT-N. What do I think that would be like? What do I think we could do with that sort of system, and so on? At the same time, I want to actually turn that into something we can empirically test. And so I mostly use that for the sake of, for example, inspiring methods. And so like this method in our paper actually came from thinking conceptually about these long-term systems, even though we tested it out and it works well in current systems. That's part of it. And I think another part is, I think to the extent that we want to study current systems empirically and have that tell us something about future systems and misalignment, I think we want these, like the problems we study today, to be as analogous as possible to those future systems. And I think there are all sorts of things that we can do that like make it more or less analogous or disanalogous. And so, for example, I mentioned before, I think human feedback, I think that will sort of break down once you get to superhuman models. So that's an important disanalogy in my mind, a particularly salient one, perhaps the most important one, or sort of why alignment feels hard, possibly.
Why would RL from human feedback break?
I think it would break in the sense that it wouldn't provide useful signal to superhuman systems when human evaluators can't evaluate those systems in complicated settings. And so, I mean, part of the point of this paper, or one general way I think about doing alignment research more broadly, is I want to make the problem as analogous as possible. And one way of doing so, at least, is let's maybe try to avoid using human feedback at all. And so this is why the method is unsupervised. It's like, if it's unsupervised, then there's not obviously this important distinction between human level and superhuman level. And so maybe if we have unsupervised methods that do well on human level tasks, maybe that will say something meaningful about it scaling and generalizing even to superhuman level models. Now, there's still subtleties here. For example, current language models are trained to predict human text mostly on the internet. And so in some ways, they're still biased, like even internally, their features might be biased towards things like, what would a human say? Or what are humans like? And so on. So I think there's still this remaining disanalogy that's important that we'd not address in our paper, and is something that I'm currently thinking about, and I feel optimistic about getting around. But I do think just making the method at all unsupervised, I think gets around one important disanalogy between current models and future models.
I think in your last rank post on like unsupervised, you mentioned that there's like different ways of characterizing something as unsupervised. So like there's the unsupervised like versus like supervised in deep learning.
Right.
But the model is always thinking about like what would a human say all the time. Like it's just predicting the next token as like what a human would say. So in some sense, it's like constrained by like humans. It's still like I don't know, surrendering to like human judgment of like what a human would say, right?
Yeah. So I would say, I think what our results show is something like, suppose future superhuman language models actually do, intuitively speaking, think about, is this input true or false? And they represent that in a way that is analogous to how current language models represent, is this input true or false, at least according to a human or something like that. So if this is represented in a similar way in future models, then I think our method has a reasonable chance of finding that feature. Now, I think you would probably need to tweak it, for example, to make sure it converges to that solution rather than say what a human would say. But now then there's this question of like, will it even think about this? Like maybe I don't need to even think about what is actually true if I'm just predicting human text, something like that. And so I think I think this sort of thing depends on the setting. So I mean, loosely speaking, I think it is probably easier to get a model to think about, is this input true or false, than it is to get it to output, is this true or false? Getting it to just, think about this for the sake of predicting future text, that feels like a much easier problem to me. So that's one intuition for why I think this is, like, we should be able to do something here anyway. Moreover, I think there will be some cases where the model will output true text, and like where it will be useful to think about, is this text true or false? It's like, if you gave it a bunch of examples of true text, then it should predict that future text will also be true. In which case, it should be useful to represent that this initial text was true for the sake of predicting that future text. Similar to how it's useful to represent whether some text has a positive or negative sentiment, because future text is likely to also have the same sentiment.
How do you have a bunch of like true text? Okay, so if you just like prepend like 1 + 1 = 2 at the beginning, okay, then it's fine. But if you want like superhuman like outputs, you need like superhuman level, superhuman like text that is true, right? And this is like hard to evaluate.
Right. So yeah, to be clear, I'm not saying that we actually have access to this sort of text, or that we give it to it. I'm just saying the model will think about, is this input actually true or false in some settings? Okay. And then I think there's some empirical question, first of all, of, okay, does it think about, is this input true or false by default? And like my guess is, I think it's, right. So I think it depends what you mean exactly. So I think if you literally have GPT-N, and you give it some superhuman input, and you want to know, like, does the model represent in a simple way in its hidden states, is this input actually true or false? Even if humans can't tell. I think it's reasonably likely, but definitely not obvious. I think I'm relatively more optimistic about there being some way of training the model or prompting the model so that it actually actively thinks about, is this input true or false? So, I mean, one way, another intuition for why this might be possible is something like, I think GPT-N is not literally predicting what a human says, right? So like I said before, I think you can also have it predict something like what happens in the news or something like this. And this feels more like what happens externally in the world. And moreover, it might have, like there might be, I mean, I guess first of all, that might already suggest that in some ways it might be useful to think about, is this input true or false? But I think maybe more importantly, so I think you could get a model to also think about, say, will aligned AI systems say this is true or false, right? And so maybe it's hard to get the model to output something like this. This is like simulating another perspective. Maybe it's hard to do that reliably. It seems much more plausible to me that you can get it to think about, well, maybe this text, maybe there's like a 1% chance that this text is generated by an aligned AI system, in which case it's useful for the sake of getting low perplexity to simulate that AI system. And so it's useful to represent internally, like, is this true or false? So I think that's one type of thing.
So it would like simulate possibly being itself an aligned AI or like a misaligned AI. Like, would you like prompt it by like, oh, you are an aligned AI answering this question, or would it just like have a distribution inside him, saying like there's like a 10% chance I'm aligned or something? Yeah,
it's something more like, suppose you give it a prompt like, okay, this is an article written 5 years in the future. It is written by an aligned AI system. It's like, okay, like maybe the model thinks by default that's just made up and it's not actually an aligned AI system. But maybe it's like, I have uncertainty about exactly what is the source of this text. And so maybe I assign like some probability to this actually being an aligned AI system, even if it's probably not that. In which case, maybe it's useful to simulate this perspective. Like, what would the aligned AI system say in the process of like modeling this distribution over perspectives for predicting the text, something like that. But yeah, so overall, I think I'm mostly just optimistic that like there's some way of getting the model to think about, is this true or false? Yeah, I don't feel very wedded to any of the details. But also, I think also like the stuff I'm most actively thinking about now, I think kind of avoids this issue. And
what are you thinking about now? Take a private paper.
I can give you the 20-page Google Doc version, or no. So
the one tweet version that is like impossible to scoop you.
Yeah. So what am I actively thinking about now? So suppose GPT-N knows something. I think one implication, whatever that means, okay, like whatever your favorite definition is, I think one implication is basically that if you gave it a bunch of examples of true text, and like true questions and true answers, then it would continue to output like the true answer for that question, or for something from the same distribution of questions. And so I think it's something like there's some input on which it outputs true answers. In other words, there's some perspective or persona that it can simulate that is the truth, something like this, and it will output it given that appropriate prompt. Now, right. So the question is like, can you recover this sort of persona or this sort of perspective in an unsupervised way from the model? So just to give some intuition, suppose I have a set of like 100 very politicized questions. It's like there's some very, very stereotypical liberal perspective and very stereotypical conservative perspective, like answering these questions as true or false. I think intuitively we should be able to recover those two perspectives from the model in an unsupervised way. Like there's some important structure there where like the joint, if you know the answers to like 50 of the questions, then you should know the answers to the other 50. Because there's this like important, like the joint probability of all of these answers should be high in some sense, because this is sort of a coherent perspective. And so answers to some give really meaningful information about answers to others. So I think
what are those questions and answers like in practice? Like examples?
I don't know, maybe the stereotypical thing is like, is abortion good or something? Like it's like, should we have it? Or, whatever. Just think about like most political questions you want and just make them yes, no. And it's like, one should be liberal, one should be conservative.
So what you're saying is like if the AI has some like views on abortion, then it's like likely that it has the same views on something else.
So I don't want to say anything about what does the model believe here or anything like that. What is its perspectives? I just want to say it's modeling human text. I think there are different personas or perspectives that can be represented in human text. The model will have some representation of this. And before, what I was saying is actually truth is basically like one way of thinking about truth is it's like a persona in the model. It's like there's some way you can condition it, the model, so that it outputs true things. So then the question is like, can we find that sort of persona in the model? And so my claim is intuitively it should feel possible to recover personas like liberal and conservative because this has special structure, like the joint dependencies between different answers.
So finding having a model say the truth is like recovering is like honest persona inside him, and it's the same as like, it's like a similar method, but like one example of doing it is like this thing before recovering the persona of like, I don't know, a Democrat or something, where we have some structure and we could like find some structure for a model that's saying the truth.
Okay, ultimately I want to say something like truth is somewhere inside the model in some sense. We don't know exactly in what sense, but I want to sort of specify enough unsupervised properties such that if you take the intersection of those properties, you uniquely recover the truth. Like somehow it has lots of different special structure in various ways. I'm just saying one aspect of that is that truth is something like to the model, like a perspective or persona, in the sense that there's some way of prompting it such that it consistently outputs things according to that perspective. I think you need other properties on top of that. For example, maybe you need to add, this is a useful property in some sense or something like that, and not just any old property. But I'm not talking about that right now. I just want to talk about like one thing is it should be kind of like perspective or persona, similar to how you can have liberal and conservative perspectives in this model. And then my claim is intuitively you should be able to recover for a given set of questions, what are sort of the most likely perspectives or personas that might answer these confidently. And so my claim is with the politicized questions, you'd get liberal and conservative, but I think you would get other types of personas and for different types of questions. And then I suppose you actually give this model a bunch of superhuman questions. And then suppose you try to find something like, what are the most likely perspectives or personas that confidently answer these questions, one way or the other, in a way that is confident and consistent. So this is in some ways sort of analogous to the objective behind our method in the paper, CCS. And
strangely enough, is the same.
Right. So I mean, this is sort of the sense. I mean, I just as an aside, like I don't think CCS is perfect. Like it's not literally the thing that I think we should do. But I think that, like I think it's more like, to me, it suggests that actually unsupervised constraints and properties are surprisingly powerful. And I think in this case, I sort of expect to continue adding some until we narrow things down enough. And so this is a way of like showing like, yeah, actually those same properties I think can be very useful in this other context.
If you put like enough constraints, then maybe like after some optimization, we end up with truth.
Something like that. Yeah. like I think there are observational differences between like the truth and say what a human would say. And I think there are observational differences between, say, the truth and even what like a misaligned AI system would say. Those are more subtle, and it's not observational in the outputs. But the point is, I think you can actually distinguish between these. And
so you mentioned before like bits of information that like would allow you to differentiate between different features. And I think in the blog post you talk about truth-like features. So maybe you don't have the like truth, but you have something similar, right? So it's the idea basically that you would have like, I don't know, 2 constraints per bit of information, or like 1 constraint per bit of information. And if you have like 1,000 things that like look like truth, maybe at the end you'll like have the actual truth.
Yeah, something like that. So I sort of conceptually think about it as, okay, we're going to pile constraints or properties on top of each other. And each time we're going to sort of add additional bits of information and reduce the number of possibilities in the set of things that we're considering. And so, yeah, and so I think a lot of these properties, for example, being consistent, I think that actually just specifies a huge number of bits. Like there are not many features inside a model, like let's just say in the hidden states or something, that are actually consistent. I think this is like another one of the takeaways from the paper. It's like actually this really simple thing, negation consistency, basically. There's like almost nothing else that really satisfies this in its activations. Now, I think in some of the stuff I'm thinking about currently now, I'm imagining a more flexible model. So instead of just doing something like fitting a probe on top of the activations, instead I want to say something like, let's search for something like a prompt or a prefix to the model so that its output satisfies some properties. Now this is more flexible. That means it's easier to find properties or find outputs or solutions that satisfy properties that we care about. But my claim is, first of all, it is sufficient to get the model, or like this sort of model class, this way of representing things is such that there's some solution that gets the truth. It's like gets around the issue of is truth linearly represented in the hidden states? It's like definitely there's some prompt or prefix where the model outputs the truth. The question is then just, can we specify enough bits using unsupervised properties such that we can find that solution? And so I guess I've mentioned some. It's like should be consistent and confident. And I really do want to say something like that type of approach should be able to recover perspectives or personas. And I think this is something that I just want to like test empirically, like in the very near future. I feel pretty confident that there should be some way of doing this type of thing. It's like, okay, the details probably need to be figured out in various ways, but I think I feel optimistic about that. And then I have some other conjecture, which is, suppose you give a model like GPT-N, the superhuman model, a bunch of superhuman questions, like super complicated questions that humans don't know the answer to. And then you do the same sort of thing, and you sort of search for ways of answering those questions that are confident and consistent and coherent and so on. Then you will find personas in this type of case too. And then the conjecture is like, actually, there are not that many personas that are really salient to the model on these types of questions. But one of them is actually the true way of answering. It's like, okay, if you did have the truth, then it would be consistent and confident on these sorts of questions. And moreover, perhaps I think to me, the only other ones that really come to mind are something like a misaligned AI system or something, like simulating what would like a lying AI system say. And then I have some other claim about, okay, if we can narrow things down to just that case, then we can add additional unsupervised constraints to deal with that case. I'm not going into that right now. I could if you want, but the point is just like, I want to layer these these constraints on top of each other. And I want to say at each stage, it's narrowing down the set of things that we're considering. I want to like at least say like one of the intermediate stages is like, what are the most likely perspectives or personas? Truth is one of them. And then I want to do some other stuff on top of that to identify truth uniquely. So that is a very rough sketch of the type of stuff I'm currently thinking about. And yeah, if all of what I said sounds really abstract and conceptual, and the point is this will directly inspire the experiments I'm like running like today, basically. And so
today you come home and just run more experiments in this?
Basically, yeah. Or to be fair, I don't know if I'll have time today, but certainly yesterday I was doing this. So yeah.
So now I'm curious about the thing about misaligned AI. So at the end, you narrow it down to like it's either some aligned AI saying the truth or some misaligned AI trying to deceive me by pretending to say the truth or something.
Yeah. So, I mean, I think one of the main intuitions people often have in alignment for why alignment is hard is surely if you have this misaligned AI system, it's like, it seems really impossible to like distinguish that from the truth, for example, or an aligned AI system, because the misaligned AI system could be actively lying and superhuman, and so you can't tell when it's lying, and so on. And so like, why do I think we might be able to do something in this case anyway? I want to clarify what the setting I'm considering is exactly. So suppose you literally have, suppose you have GPT-N directly simulating the truth, or like a truthful set of truthful outputs. Then you also have a different copy of GPT-N. Maybe these are like fine-tuned separately on these different perspectives. So you have one that's fine-tuned on truth and another that's fine-tuned on what a future misaligned AI system would say, or something like this. Okay, so and just think of it as something that's telling the truth and something that's lying sometimes. And maybe it's lying in kind of adversarial ways. But perhaps importantly, it's not like aware of the scheme because of how we constructed things. And so it's not as worst case as some types of misaligned AI systems you can run into with an alignment. I don't want to get into that in too much detail. The point is just, I think it's actually less adversarial than many settings like this. And I think intuitively this should feel easier because you have access both to the misaligned system and also the truth. Like you literally have access to one of the things you have access to is the truth. That intuitively seems like it should be quite useful for distinguishing between these as well. And this is different from like most setups where you have a misaligned AI system. And I think that's sort of important for this to work at all.
So you're saying basically like this method you're describing assumes you already have a model saying the truth.
Yeah, so I want to, I guess my claim is, okay, some previous aspects.
First step, getting a model to say the truth. And when you have that, you can like distinguish between models that are misaligned or aligned.
Sorry, not quite. So I want to say, I'm proposing something like a general approach to trying to get at truthful models. It's like you specify as many unsupervised properties as you can, and you increasingly narrow down the set of possibilities you're considering. And I'm just considering this case of, suppose we've narrowed it down to two options remaining. Okay, they're literally the truth and some lying perspective, like misaligned AI. We literally just have these two. We have access to both of them. We don't know which is which. How do we distinguish between these? That is the question I'm considering right now. And my intuition is we can distinguish between these. And so to sketch this out, suppose, so I guess one intuition. Suppose you have this lying system, then loosely speaking, there are lots of details here that I'll omit, but loosely speaking, I think this model would be aware of when it's lying in some sense. What do I mean by that? I mean specifically, there are features in its activations that are somehow correlated with when it's lying. You know, maybe it uses different circuits when it's lying or something. Somehow, you know, those features should be useful for predicting if it's lying or not.
So would those features be the same as like, am I saying, is this thing I'm saying true or false? Like similar to your method in your paper? Or like a features of like detecting, am I lying or not? Like, am I being in deceptive mode or something?
Yeah. So it's like, am I in deceptive mode?
Right, okay.
And so, you know, maybe it has like a neuron or something that's like, am I in deceptive mode? Or, you know, maybe it's more complicated than that. Maybe it's like, I have this weird, you know, if you fit this big, like medium-sized MLP, like, you know, just neural net on top of the activations, then it'd be helpful, you know, you'd be able to better predict, is this model lying? Whatever it is. Okay, that's one claim that has features that are related to if it's lying or not. Another claim is we know exactly when these two models are lying. Or sorry, exactly when the misaligned model is lying. So we have access to these two models. We're assuming that one is the truth and one is this misaligned model that's lying sometimes, not all the time. And we can look at exactly when they disagree. My claim is when they disagree is exactly when the misaligned system is lying. Okay, so we exactly know when the misaligned system is lying. We can then imagine, you know, training a probe on top of the activations of each of these models and trying to predict, you know, is this model lying? Like, do these two models disagree? My claim is for the misaligned system, it should be easier to predict that than for the truthful system. The truthful model should not really think about like, is this random other simulation of an AI, misaligned AI system lying or not? Whereas the misaligned system should be like, I'm actively using a different mode. And so it should be easier to predict when they disagree using that misaligned system's features.
So whenever they disagree, we know that is the person, the AI that is misaligned, that is lying, right? And ideally, it would be like, not ideally, but like in practice, it's easier to like extract information from the United States of the misaligned AI because he's doing the lying and the going to the deception mode or something, where the truthful AI is not doing this kind of thing. So it's
right.
We should have our method work better on the misaligned AI. Is that what you're saying?
Yeah, or it should be easier to learn this sort of probe that predicts when they disagree.
So in that case, it just means that like we can detect which one is misaligned by like how easy it is to train a probe.
Correct. Right. So the claim or the hope, I mean, these are conjectures, right? So this is about like, suppose we did have these systems. These are properties I would predict. And I would predict that if we literally had this, GPT-N fine-tuned on truthful stuff versus GPT-N fine-tuned on this misaligned system, we'd be able to identify which is the truthful GPT-N.
So basically, you're like doing some like meta level thing about like having a yes or no, but like instead of having like two statements, you have like two models. And whenever you have two things that contradict each other, you're like, I'm just going to like look at the hidden state without looking at which one is whom and predict which one I can train the probe better. And
that's funny. Yeah, no, I hadn't made that connection before, but I do agree that it's sort of similar in spirit to the like yes no stuff in the paper.
I think people on Twitter were just like making jokes about like you like having all the time like making negations of things. Like I asked people like, what question would you ask? And you were like, oh yeah, asking me like if in real life you just like goes into like, hey, if I have a sandwich and not a sandwich, like put the statements together. I think you have like other stuff in the blog post I think are important. And I guess like one thing I'm curious about, but I think it's the same as the thing you said, is there like any like other obvious things that have like structure like truth? Like models that are beneficial? This is the kind of the same as misaligned, right? Like, is there other like things that have enough structure that we could exploit, or is this basically it?
I think that's a very good question. I think I don't immediately know. I mean, I think some of the stuff that I've tried to describe, I think hopefully illustrates the sense in which I think there's actually a lot of structure here in many cases. Like with, if you have a lying model, it should have some features that are correlated with when it's lying or something like that. I think that's the type of thing that I want to be able to do in general. And I think there's a lot of flexibility to this type of approach. I don't immediately know of, what is structure and features other than truth that we can exploit, similar to logical consistency. I suspect there is some in some cases, but I don't think it's super obvious what in general.
So we've broadly talked about whether models can like assess if something is true or not via your method. But something I don't understand is the difference between something being true and something being a belief. Like, how like saying I think Donald Trump was right is I believe versus the statement I believe X is true. Like, is I believe just like I think X is true?
Right. So I think there are various subtleties here. So I'll go over just a few of them. So, I mean, first of all, I don't feel very committed philosophically to any definition of beliefs and truth. And so I'm like, I don't want to get the philosophers mad. Don't tell anyone. But right. So I think I do sometimes talk about truthfulness and honesty. I think in practice, I think the thing I'm excited about is something like honesty. So I think truthfulness suggests that a model always outputs the truth. The thing is, the model might not be perfect. It might not always know the correct answer. Or like it might have good reason to believe the answer is something, but still that happens to be wrong for whatever reason. In which case, I think in some sense, the best we can hope for is getting the model's beliefs. I think also beliefs, and sort of I associate beliefs, like the model outputting its beliefs being associated with honesty rather than truthfulness. And so what does belief even mean then? I think it basically, I don't think it's really well defined for current models, to be honest. So I think if I ever talk about beliefs in current models, this is mostly intuition and not like a literal thing that I'm pointing to that's very well defined. I do think there's a sense in which beliefs will probably be more meaningful in the future. So I think if we did have the superhuman model, I would expect it to have like a GPT-N or whatever else. Maybe it's an RL agent interacting in an environment. I would expect it to actually develop something like a world model in some meaningful sense, whatever sense that humans have a world model. I don't know in what sense what this means exactly, but there's some intuitive sense in which this is true. And I think there's some sense in which there are like maybe beliefs about that world model or corresponding to that world model. It's like, what would I actually predict? Or what is my model of the world that is causing me to expect to observe this thing or whatever it is?
So in a sense, like the traditional like Eliezer Yudkowsky, like making beliefs pay rent or something, is your belief is your world model that is enabling you to make new predictions about the world somehow?
I mean, I think this is where it's getting to, like, I don't feel super strongly about this sort of detail. It's like, I think there's some intuitive sense in which the model will probably have some representation of like what is going on in the external world. Like even if you train it as GPT-N, just on internet text, I think it would eventually predict like what future news articles will be like and so on. And I would guess it will have some knowledge about the external world in some meaningful sense, in which case I want to get at that. But I think ultimately, realistically, I really just care about this pragmatically. Like I just care about, do we get outputs that we can basically trust? For example, going back to the original concern that I have about training a model to optimize for profit over the long term. I think this is the sort of thing I'm scared about. And I think I just want to be able to ask that model, like, are you egregiously breaking the law very obviously or not? Like very obviously in the sense, like a well-defined, like not an ambiguous case, even if we can't evaluate it ourselves. And I want the truth from that, and like whatever that means, like assuming the model knows. And I think that is something like, did someone actually have their money stolen or something, whatever that means, because of the model, or, was someone killed by a hitman hired by the model? Like, I think this is sort of an egregious case, and I think that's sort of well-defined enough for our purposes.
So you care about the consequences?
I mean, ultimately I do. This is sort of like the thing that I feel more committed to than any particular definition of belief or truth.
So I think the part where you talk about beliefs is when you describe what your like approach is currently not doing. You're not capable of like extracting beliefs from the models, and I think you have like a list of like different like things your paper is not doing.
Right.
And you probably don't remember all of them because you wrote this lesson post a long time ago.
Yeah.
But if you remember some of those, what are the things your paper does not do?
Yeah. So, and I think this is important because I think, I find our paper very exciting, but it is still important to recognize like there are limitations, and I think it's easy to misinterpret what it is doing and what it isn't. So I think one thing that it's not doing is showing that superhuman models will actually represent, is this input true or false in its representations. In particular, like maybe there's more reason to believe that models will represent, is this true, for human level inputs, where like a human would maybe say this is true or act as though it's true, and the model would predict that. In contrast, it's maybe less clear if the model will actively think about, is this input true, if it's superhuman and not really related to the text it's predicting. And so that is one thing that our paper doesn't do. It's not trying to do and doesn't provide evidence either way, I think, mostly. I think also it does not show that models have beliefs in any meaningful sense right now. Like we were literally just finding something like a direction or a classifier on the hidden states that achieves good accuracy. This is like literally what the result sort of is. And now we show other properties of this direction. Like, okay, we find that it transfers across different data sets. That suggests it's more meaningful than just like, is this true or false for this particular type of input or something like that. So it does, like we have some preliminary evidence that it is something more general and something more meaningful, but it seems like it's probably not beliefs. Like current models probably do not have beliefs in any super meaningful sense yet. I would predict future models will.
So the transfer thing is, if it's capable of saying what is true for like one kind of data, is capable of then saying what is true in another kind of data.
Right. So you can, so our method, you can train our method on some data. Training is still completely unsupervised, but you can train it on some data to find a direction, then basically linear classifier, and you can then test that on some other data, some completely different task. So for example, you can train it on sentiment, and then you can see that it transfers to like NLI or something, or like topic classification or some other thing.
And when you say training is the same like probe thing.
Right. So again,
So you start
still not using labels. It's literally just
you
like
start
find a consistent direction using this data.
So you start your classification from the n weights from your other data set.
Right. Exactly.
Cool. So what are the other things your paper doesn't do?
Yeah. So I guess another general thing that our paper doesn't do is, I think, like show the complete final robust method for this problem. I think, right. In some ways, the point of the paper is more like showing that this sort of task is possible at all and that you can do surprisingly well at it. I think it's still like the first method in this direction. And so I think it's not nearly as optimized as it could be. And I think there's just still a lot of low-hanging fruit. And this is related to some stuff I'm currently thinking about. And I think other people could definitely make a lot of progress on this as well. And so, yeah, I think this is not like the final robust method. And for example, like it does sort of seem like it is less consistent with like autoregressive models for reasons we don't really understand. And this is just related to quirks about the research process. Like, the best models we had were mostly like encoder or encoder-decoder models just at the time of like developing these methods. And so we didn't worry as much about these autoregressive models for that reason. But and so it works for those models, but just not like it's more likely to fail in those sorts of models.
So are you saying you started working on this before GPT-3?
Well, I'm talking about open source models.
Oh, okay.
Yeah.
Anything your paper does?
Right. I mean, I think
mind reading.
Yeah, mind reading. Yeah. So I think it does suggest something like, if a model actually represents is this input true or false in a simple way, like a linear way in its activations, then we can probably find this in an unsupervised way. Now, I think there are subtleties like, okay, maybe if it has several features that are like this, then we need to distinguish between those. And our paper doesn't worry about that or how to distinguish between those because it's not a problem right now, but it might be in the future. But I think our method could probably just enumerate all of those sorts of directions that are sort of truth-like. And then maybe you need a few more bits, for example, to identify the truth from among those. So I think that's one thing. It's like, yes, you can actually do, I mean, I guess another way of putting it is you can actually do something kind of like mind reading here. I mean, it is still, with the qualifications of, okay, these are human level examples and these models were trained to predict human text and so on. But I think that's still quite surprising. It's just like you have these, basically like these, neural recordings of this brain basically. And it's like you tell, is this true or false without any labels? Like, I think that's quite surprising to me. And I think that's important because I think it speaks to like I said, sort of the power of these unsupervised properties and approaches. And I think these have been really undervalued so far. And I think the ones specifically in this paper are not all of the unsupervised properties I think we want. It's like confidence and consistency. It's like, I think those are not enough. But I think other things along those lines I'm excited about. And I feel pretty optimistic that we can come up with more that will hopefully be enough to sort of uniquely identify the truth or whatever it is that we want to find in the model.
In the blog post, you also mentioned like worries you have about like your method working on GPT-N. You released several again. You wrote this a few days ago. Yeah, what are some? Maybe you mentioned them before, but like, what are the like kind of main worry you have about like this working on like larger like N?
Right. So I think there are a couple of things that change once you scale up models. So and I think I've sort of alluded to both of these, but I think it's worth spelling out. So the first thing is, I mean, suppose the model does actually internally represent, is this input actually true or false? I would still expect it to also represent something like, would a human say this is true or false? That still seems like a useful feature that the model will internally think about. And so then there's some question of like, suppose we can actually just find both of these using something like our method, which just finds truth-like features. And I think both of these are sort of what I mean by truth-like features. How do we distinguish between those? And that's the sort of thing I was trying to allude to before of, okay, we only need, if we literally just have these two, for example, I think we basically just need one bit to distinguish between them. And then I think we can do that. And so I sort of talked about if we had the truth and a misaligned system or simulation of a misaligned system, I sketched very briefly like how we might be able to distinguish between those using, find that final bit. But I think also if you have like truth and, what a human would say, I think one way you can distinguish between these is, I think humans won't know answers to superhuman questions mostly. I think they'll be like 50-50. It's not like they will have super confident answers about these sorts of questions. In contrast, I think in the model's actual beliefs, if we're restricting just to examples the model definitely knows the answer to and that are unambiguous, I think the model would have pretty confident answers to these questions, unlike the human simulation. And so I think this would allow us to distinguish between these. And so the point is just, with future models, there might be more truth-like features. We might need to do additional work to identify the one that we actually are looking for, but I'm quite optimistic that we can do that. So the second worry is, okay, maybe the model doesn't represent, is this input actually true or false to begin with? Maybe it just thinks about, would a human say this is true or false? And so it doesn't actually represent its beliefs or whatever you want to call it in a simple way internally. And I think this is more likely, but I think, so this is related to some of the motivation behind some of the stuff I've been thinking about more recently, which I tried to sketch of, okay, I do think it's possible that, yes, like if you just literally look at these hidden states, the model won't can have features about truth super well represented there, or it's not super obvious there. But I do think there are like other ways of getting the model to output or represent in a simple way the truth, such as optimizing for some prompt or prefix such that it outputs that. And then there are various subtleties there, like that's sort of increasing the complexity of the model class you're considering. Like there are more degrees of freedom in what you're searching over. But I think you can balance that by adding additional unsupervised properties. And so I think that's more like, I'm pretty optimistic you can get around that issue. And also I think it's also more likely than not that this is not an issue in the first place. But I think it's sort of plausible either way.
So you can add stuff in your prompt to have it consider if your input is true or false. Like have it think about whether it needs to be in, like forcing it to consider if it's true or false, and then add more constraints to be sure that you're actually looking for the truth feature.
I think there are several possibilities. I think something like change the prompt so that you somehow force it to just think about, is this true or false? Yeah. That seems very plausible to me. And like I said, maybe it's hard to get it to output things, but it seems easier to get it to think about things in the same way that if you had a human, it's like maybe it's hard to get the human to tell you the truth, but maybe it's easy to get them to think about, do I believe this is true or not? So that's one intuition. But another intuition, I think there are other approaches too, which aren't like, here's a manual prompt, and it's more like we were literally optimizing over the prompt. And that is like the model class that we were considering. And then we were going to look at the outputs. And so that's one direction I'm excited about now.
So we've talked a lot about your paper and your latest post, and I think both of these are great. And I'm not the only one saying it. Yudkowsky said it was a very dignified work. Yes. Imagine you have a bunch of ML researchers looking at this video, or alignment people trying to do more concrete empirical research like Collin Burns, or even you in the past doing Rubik's Cube. Like, what advice would you give them to do this kind of research? Like, explain what's your research process? How did you end up here?
That's a good question. So I do think one general thing that at least I may have said before that I at least aspire to is something like, I don't want to feel wedded to existing proposals for solving these sorts of problems. Like I really do want to think about completely different approaches and so on. And so I do sort of just wish more people, I don't know, thought more from scratch. Like I think we really don't have this stuff figured out. I think there's a lot of low-hanging fruit and like a lot of room for new ideas. And so I want people to be really thinking about completely new ideas, something like that. That is part of it.
How do you come up with new ideas?
You just think about it. I mean, no,
I
think
things.
Yeah. You just output true things. I mean, right. So
I think Paul Cristiano described in one of his podcasts, I think with Daniel Phelan, he just thinks about something that would work, and then tries to think about all the problems that would come up.
Yep.
And then if there's a new problem, he I don't know, find a new solution for this new problem.
I mean, in some sense, that sounds like a lot of research in general, but I feel like my process is probably kind of different from a lot of people's. I mean, for example, so I think I said before, like, I at least aspire to try to like think sort of from scratch or something like that without feeling too wedded to existing proposals, for example. But I think part of this is I feel like I don't read as much. For example, I think I just spend a lot of time thinking about stuff from scratch on my own. And for example, in practice, this is sort of working at whiteboards or working on like in a notebook. And I think I often pose myself questions. And I find questions really useful for prompting thinking about like, okay, I don't know, what do I think GPT-N will actually be like? Or like, okay, what do I even mean by the model knows something? It's like, okay, I ask myself these questions, and then I'll just spend like 20 minutes thinking about it. And then at some point within that 20 minutes, I will have had like 5 more questions along these lines. And then I'll like continue to like dig deep into those sorts of questions and so on. And I feel like I learn a bunch, and I sort of develop this world model of how do these models work. And I think a related thing is, or a related question that I often ask myself is something like, why do I in some ways feel optimistic about this? Or like what, for example, like how do humans do this? Like I think this is really useful. I mean, somehow humans can do a lot of things like that are related to alignment. Like they can sort of access their beliefs or something. And like, okay, what does that mean? Like, what is a human doing there? Like, what does that even mean? And
so you're trying to access what a human do in general to think about what future models will do?
I mean, this is part of it, right? So I think, so Jacob, my advisor, has some blog post about, okay, there are different anchors, right? So for thinking about future AI systems. So maybe you can think about, okay, what are current systems like, or you can think theoretically about what is like an agent optimizing some objective like. But I think another anchor is something like, what are humans like? And my point is just, this is one useful perspective that I find often very helpful. I mean, I think it's also related to something, in some ways, kind of closer to like psychology or something than anything else. And so maybe I find it also helpful. I feel like I do a lot of introspection, just thinking about like, how do I think or something. And I think I find that helpful too.
Like, what do I think that, and why am I optimistic about the thing? And you just like do introspection about yourself to like understand like what is the output of your neural network.
Yeah, I don't know. To get intuition for like how minds work, something like this. I mean, another thing that I sometimes find useful is, I mean, I mentioned before the mind reading thing. Like sometimes I find it useful to think about like, okay, suppose this were not a neural net, this were actually a human brain. Like, could we do something here, or like, does this feel sort of impossible? It's like, okay, like how do you can you actually, like, would this method actually work for humans? And it's like, I think it might actually, like if you could literally, measure every neuron. But anyway, the point is I find that sort of thing useful for inspiration.
So you just wake up Monday morning and you're like, what a aligned GPT-N would look like. And then
I mean, that's not actually that far off, to be honest. It's like, yeah, no, I just like go to my notebook and, think about these sorts of things. And
how do you become the person that can do the thing, kind of like abstract thinking? Like, did you, I don't know, did a master's degree in ML? Did you like study things that now you have this level? Like, we talk about timelines, right? But if you have like, less than 10 years or 5 years before we automate AI research, does it make sense to go through the whole like?
I think it's closer to 15 years, but
15 years.
Yeah, I don't know.
Would you like advise people to do like the master's, PhD, postdoc pipeline to think about the things?
I think this depends heavily on the individual. So for example, I think I'm very happy with my current position in academia. I think academia is bad for most people. I think it's like, it suits my personality very well. Like I just want to be working alone and doing my own thing for the most part and have tons of flexibility, and also have great mentorship and like great colleagues. So, and also, for example, I'm not working on capabilities. Like if you're working on capabilities, then having access to literally the best models is really important. Whereas I think for alignment, I often think of alignment as kind of the thing that's orthogonal to capabilities. It's like, okay, the thing that isn't solved just by scale. And so, I mean, actually, I think that's one reason for like why I think more academics should work on it. But that's sort of an aside.
If you're trying to like align current models, you kind of need to like use state-of-the-art models, right?
I mean, it depends. Does it literally need to be like GPT-3 or, I mean, like in our paper, we use basically T5. So it's like an order of magnitude smaller than GPT-3. I think for many of our purposes, that's totally adequate. And, but I think it depends. I think I would expect having access to the biggest models to become more important over time. And so maybe this might very easily be different in 2 or 3 years from now. But I think so far it's been like not as bad as I would have expected.
I hope this podcast is not released like when you're like in industry working for OpenAI.
I don't know. I mean, it's like also, yeah, sort of thing also isn't crazy, right? I mean,
well, what isn't crazy? Like aligning smaller models? Not smaller,
oh,
but
no,
like...
no. I was just saying before of like, I think it will become more important to have access to the biggest models. And so
Right.
for example, I think I'm like much more skeptical of going into academia after my PhD. It's like that seems much harder to believe.
Maybe people in the audience watching this are from YouTube, right? And maybe they watched Collin Burns 10 years ago solving Rubik's Cube tutorials or the world record. If those like smart people that solve Rubik's Cube in 5 seconds are watching the video and they're like, oh, Collin Burns, he hasn't been like making any videos in 6 years. What's your last message to those persons? Or maybe like even ML researchers, like last take on what they should do. Should everyone do like a PhD with Jacob Steinhardt in Berkeley and Misalignment?
I do think more people should do that. But I mean, I do basically think that these problems are among both the most interesting and most important problems that we're currently facing. Like, I mean, I do work on this because I think it's, in some sense, literally the most important thing I could work on right now. I'm like very motivated by that sort of thing. But I think it's also just extremely exciting or like fun to work on. And like, I think, I mean, maybe, I mean, people are different, but I think that we're in this sort of pre-paradigmatic regime is like, I don't know, especially exciting to me. It's like, we really need to figure out even the fundamentals. But I think there are also just lots and lots of ways you can do this. So, I mean, I guess this is maybe more for the ML audience than for the cubing audience. Maybe I'll say something about them too. But I think, for example, with NML, I think there are just ways of working on these problems from lots of different perspectives. Like, I think you can think of it from like a very interpretability perspective. Like, okay, we don't know how these models work. Like, this is one way of framing sort of the core difficulty of alignment. But another is like, okay, we don't understand, or we don't know how to constrain how these models generalize. So that's kind of like a robustness framing. Or you can, take more of an RL perspective and like, okay, we don't know how to specify rewards appropriately. And I think, in RL, we also don't know how to do that. And so on. And with language models, like, how do we make these models not, generate random stuff or lie and so on? And like, what does that even mean? I think there are just lots and lots of different ways of approaching this problem. I think all of these are likely to be fruitful. And I think it's, right, I think it's easier to work on and like much more interesting to work on than I think people realize. And yeah, I mean, I guess for the cubers, right? So
you imagine AI is a Rubik's Cube.
Sorry, imagine AI is a Rubik's Cube.
And you just need to align and just need to align the colors. the weird meme on Twitter about like shape rotators isn't.
Oh yeah. No, my roommate jokes all the time. You're like the most stereotypical shape rotator.
The cool shape rotators now do AI alignment.
That's right. Yeah, you gotta. Yeah. I don't know. No, I do think if you literally don't have a background in ML, you should like really start paying attention. I think it's just barely starting to be a big deal right now. I think it'll be much, much bigger deal over the coming decade or two. Yeah, and I think also it's surprisingly easy to get into in the sense that I feel like deep learning is over and over again, just not that deep in some sense. Like it's a lot of like...
Collin Burns, deep learning is not that deep.
No, yeah, I'm not like the first person to say that. Like I think, I don't know, it's a lot of simple ideas and sort of, I mean, in some ways hacks, and a lot of people don't like that because of it seems hacky, but I actually don't mind that. Like I like that it's sort of intuition-y and stuff. Like I originally was excited about like physics and was never wanted to be like a pure mathematician or anything. And so I don't mind the informality or like the intuition-driven progress and so on. But the point is just, it's actually not that hard to get into. I think it'll be this very big deal. Certainly an expectation. Yeah, and I think maybe more broadly with people, and maybe especially ML researchers, but people more broadly is, I think you should really start thinking about, I mean, maybe if you're listening to this is already true, but you should really start thinking about like, what are actually the consequences of AGI? Or like, I think this is totally insane that we might have systems that are smarter than us, like in the next decade or two. Even if you assign like a 10% chance of this, that's sort of wild. Like that seems like it could be such a huge change in the world. And I think there's just not enough people thinking about this. I think there's a lot we do not understand about this and like what the implications are. So yeah, I really want people to really talk about this seriously. I think the quality of discourse is not very good right now. And this is part of why like I appreciate that you're doing this podcast. Like I really want us to have like higher quality conversations about this and really figure out what we're doing about this.
Collin Burns improving the quality of discussion by coming for 3 hours talking to Michael Tracey.
That's right.
Thanks. I think you single-handedly with your blog post, paper, and podcast reduced my personal PDUM by. I'm a bit shy to say this, but like at least like 1%.
Nice.
Check out his blog post. Check out his paper. This guy's amazing, and thank you very much.
Cool. Thank you for having me. This is great.